26 FPS, 60 FPS. Done. Okay, there we go. It just started going now. It's showing an empty stream, but it just started going. Why is it showing an empty screen though? Connect streaming software to go live again. Okay, no, it says I'm going, but it's also showing an empty stream. Let me go to my YouTube channel again and see if it shows me live there now. It still doesn't show me live here. Okay, no, it shows me live here now. No, it says I'm going. Oh, okay. But it's also showing an empty stream. All right. Also I'm peeking. Why am I peeking? Let me turn myself down a bit and turn the music down a bit as well. Okay, you can stop. Yeah, YouTube's going. YouTube's actually going now. I don't know what happened with YouTube there, but it is actually going, and Twitch has been going this entire time, so we're good. Yeah. And Discord hasn't picked it up yet, but that's okay. Discord will eventually pick it up. I don't know. Discord, it's weird. Tech is weird today. I don't know. It's like Mercury retrograde or whatever. I don't actually know how any of that works, but it probably is Mercury retrograde or something. Somebody with like actual information on that stuff, please let me know if it actually is. Yeah, I can just Google it. Like, is it Mercury retrograde today? It just says May 2nd. And this one just says yes. For August 28th. Hold on. I thought someone knocked at the door. Maybe I might be being too loud. It's possible that I'm being too loud and someone actually did knock at the door because I'm being too loud. Who knows? Who knows? We'll find out eventually when there are complaints. Right now there are none, so we're good. Okay, anyways, I need to now figure out, so now that we have like the entire like YouTube and Twitch thing sorted out, which let me pause my stream on Twitch as well. Also, yeah, we need to check that the chats are merged, so I'm gonna go type yo there and then yo YouTube, and hopefully both of those show up. Both of those do show up. I need to make it so that I can actually see both of them showing up as well. Woity Poyo. I'm assuming that's someone from IGDA PK. Because same name and stuff. I assume so. Anyways, let us figure out how to actually frickin' watch this old man explain how to put an input output thing through assembly on the screen on this virtual computer. So we're doing assembly code. Just turn down the thing. Oh, sure, cool. Yeah, I figured. I figured. That also probably means that the Discord thing is not working. Yeah, Discord does say that I'm live on YouTube for some reason. I didn't know YouTube was linked to my Discord, to be fair. So I'm assuming you're typing on YouTube. I'm live on both Twitch and YouTube right now. So either is fine. Either is fine. It's just, it's strange that Discord picked up YouTube instead of Twitch, because usually it picks up Twitch. Although sometimes it's a but. It is a but sometimes. Thank you for the theme. I don't know what theme you're talking about though. You mean my Firefox theme? Thanks. Aight. I need to get rid of all this like drama stuff that I was looking at. I'm looking at a different screen, by the way, that you guys do not see, where most of this stuff is going on. So if I'm looking over here, even though it probably looks like I'm looking at the camera, right now I am looking at the camera. I'm looking right into your eyes. But mostly I'm just looking at a screen that's over here that you guys can't see because I'm not sharing it. I'm not gonna share it. But anyways, I just need to figure this out. Let's just watch this real quick. Isn't that against YouTube streaming laws? Nope. The multi-streaming thing used to be against Twitch streaming TOS for a really long time, until TwitchCon last year, where they were just like, you know what? Nobody cares. Go multi-stream. Live your lives. Also, we're gonna be silent for a little bit.
Computers are equipped with all sorts of input-output devices, and likewise, the head computer can also be connected to some input-output devices. And in this unit, we're going to talk about how we use machine language to control and manipulate these I/O devices. So we start with the basic architecture that we've seen all along, but now we're going to extend this architecture with two fancy I/O devices. We're going to have a display unit similar to your screen, and we're going to have a keyboard which is actually identical to the keyboard that you are currently using. These devices are sometimes called peripheral because, as you see in the picture, they exist outside the computer. They exist somewhere in the periphery of the computer. And here's how we actually devices are sometimes called peripheral because, as you see in the picture, they exist outside the computer. They exist somewhere in the periphery of the computer. And here's how we actually use them. Well, obviously, we use the I/O devices in order to communicate.
Okay, I seem to be stable now, but I had a million dropped frames there for a minute. Like, not a million, 800 dropped frames, but I was dropping every single frame there. I don't know. It seems to be fine now.
With the user, we show some pictures or animations or anything that we want to show to the user using the display unit, and we acquire inputs from the user using the keyboard. Now, obviously, we have some more devices like a mouse and microphones and so on, but for now, let us talk only about the two sort of most important device units, which are the display unit and the keyboard. How do you control these devices? Well, if you're lucky to work in a high-level environment, if you use languages like Java or Python, well, in that case, you have numerous libraries that provide all sorts of fancy way to manipulate these devices. You can create graphics, animation, audio, video, and so on. However, if you work at the low level that we are operating on, the only thing that you have is bits. So you have to be very clever about it, and you have to figure out a way to use these very Spartan zeros and ones in order to do something useful and display and acquire information from users and to users. Now, you may be wondering, how do we use the high level in order to manipulate I/O devices? Because this is also something that we have to learn and understand. How these libraries work. How do you draw a line? How do you draw a circle? And so on. Well, this is something that we deal with in the second part of this course. So if you want to learn about the software hierarchy, if you want to learn about the design of high-level languages and the I/O libraries that extend them and how they operate also, how they communicate with the operating system, this is something that we do in the second part of this course. In this part of the course, we deal with the hardware only. So once again, in this course, we're going to talk about the very clever ways in which we use bits to manipulate these devices. So the first thing that we'll talk about is how to manipulate the output, or how to manipulate the display unit, also called screen sometimes. Well, how do you do it? Well, the most important player in this game is something called a screen memory map. And a screen memory map is a designated area which is part of the data memory of what we sometimes call RAM. So the deal is such that the physical display unit is continuously refreshed from the contents of the memory map. And this happens many times each second. So if I'm a programmer,
I just
and
want
I'm
to know how to do it in code. Just tell me how to do it in code.
Simply manipulate
That's
some
all
bits
I want to know
in the
right now.
memory map, and I can count on the fact that
I
in the
know
next
all
refresh
these
cycle,
things.
what I
Just tell
change
me
in
how to
memory is
do
going
it
to be
in the
reflected on
assembly
screen.
code so I
Now,
can
obviously, I
go
have to be very
do
careful
it.
about it, and if I want to write a text like "Hello World," well, it's going to take a lot of work. I have to turn on and off pixels in very specific locations in order to affect this
I
particular
need to
output.
know how to run
So we'll
both
do
the
some of this
keyboard and the
today,
screen.
and we'll do some more fancy
Essentially,
input-output operations, some
that's
much
the
more
goal
fancy
for today.
operations in the second part of this course, as I explained.
I keep
as I explained
feeling
earlier.
like I'm
All right,
dropping.
so let's delve into the screen memory map. Now, this is how we are used to think about display units, but as far as the hack computer is concerned, the display unit is the following abstraction. It's a table or a matrix consisting of 256 rows and 512 columns, and in each intersection of a row and a column we have what is known as a pixel. This is a black and white screen, so we can either turn the pixel on or we can turn it off. This is the physical display unit that the hack computer assumes. Now, how do we control it? Well, as I just explained, we have something called a memory map, and the memory map is a sequence of 16-bit values.
We go for a while. I could order something to eat.
8K
I'm not hungry
words.
right now.
Why do we have 8K 16-bit words? Because it turns out that 8K times 16 gives something like 13,000 and something, and this is the number of pixels that we have on the physical display unit. So for every pixel on the physical display unit, we have a bit that represents this pixel in the screen memory map, and if I want to turn on this pixel, I put 1 in this bit. If I want to turn it off, I put 0 in this bit.
So between 16, 3, 348, which is what we had over here as well, right? 16, 384. From 16, 384 up until there, I'm assuming? No. What did he say?
In order to understand 16-bit words, now how do we control it? Well, as I just explained, we have something called a memory map, and the memory map is a sequence of 16-bit values. Every one of these values is sometimes called a word. So we have altogether 8K 16-bit words. Why do we have 8K 16-bit words? Because it turns out that 8K times 16 gives something like 13,000 and something, and this is the number of pixels that we have on the physical display unit. So for every pixel on the physical display unit, we have a bit that represents this pixel in the screen memory map, and if I want to turn on this pixel, I put 1 in this bit. If I want to turn it off, I put 0 in this bit. So in order to understand and control these bits judiciously, I have to come up with some mapping that describes exactly which bit corresponds to which pixel. Now, this is a little bit involved because on the right-hand side, I have a two-dimensional abstraction, and on the left-hand side, I have a one-dimensional abstraction, and I somehow have to connect the two. So how do we do it? Well, first of all, you should notice, and I'd like to re-emphasize the fact that when we access memory, we can only retrieve 16 bits in one chunk. We cannot access individual bits. If I want to access an individual bit, I have to figure out, first of all, in which word this bit resides, so to speak, and then I have to retrieve the entire word, do something to this value, and manipulate this particular bit, and then I have to take this value and put it back, write it back into memory. So the read-write operations are always 16-bit operations. So I take the 16-bit out, manipulate something, and put it back. All right. So what is the mapping? Well, here it is. The first 32 words in the memory map correspond to the first row in the display unit. Okay. So the first pixel that we see here, and actually you can see it in the picture. We see that the picture begins with 4 black pixels, and indeed we see 4 ones at the top of the memory. Then we have.
So it's like, but it's not just a 1, because it's a 16-bit value. So it's not just a 1, right? It's like, what's the highest 16-bit value? 256, I think. It's up until 256. So is like 1 like 256, right? If I put in 255, would that mean that the pixel goes black? I don't know. He's gonna explain it, I guess.
0, 1, 0, 1, white, black, and so on and so forth. Okay, so that's row 0. Then we have row 1 all the way down to row 255. Okay, so that's mapping that we have to bear in mind. Now, suppose that I want to manipulate a certain pixel on the screen, and pixels on the screen are characterized by a row and a column. How do I map this row-column pair on the right register in the memory map? Well, here's how I do it. Well, first of all, I multiply row by 32, and then I compute column divided by 16. And this, by the way, is integer division. Namely, I throw away the remainder of the division. So, for example, if column equals 18, then 18 divided by 16 is 1. So I take the result of this integer division, I add it up to 32 times row, and this gives me the address of the register that I have to manipulate in the respective memory map. Now, notice the word screen. What does screen means here? Well, in the hack architecture, and in this course, we are going to implement the screen memory map using a chip called screen. So we're going to have an 8K chip called screen, which behaves exactly as a memory unit. We can retrieve data from it, you can write data into it, and this chip will serve as our memory map. However, when we build the overall computer, this chip is going to be part of the data memory. So the data memory, or the RAM, consists of several chips, and the screen will be one of them. That's exactly how we described it before. We said that the memory map is part of the data memory. But notice that once you take this screen chip and put it in a larger memory context, the base address of the memory map changes. So if I access the screen chip, I use the address that you see here. But if I access the overall RAM, I have to take this relative address and add to it the base address of the memory map in the overall memory, which happens to be 16384. So this is just a technical detail. If you want to write to the screen using the screen chip directly, you use the first algebraic expression, and if you want to, if you are told that the screen is part of a larger memory, you have to add up the base address.
Okay.
All right. So we have this 16-bit word, and then we want to manipulate a particular bit inside it. Which bit is it? Well, it turns out that this bit is the column.
I want to do all of them at the same time, though.
Remains after we divide column by 16. So we get a number which is between 0 and 15. We manipulate this bit. We turn it to 0 or to 1. We take the resulting value and we write it back into the RAM. Okay, that's if we won't do it, we won't achieve anything, right? We have to somehow write it back into the memory map, and in the next refresh cycle, what we just did is going to change the pixel in the outside display. I guess that some of you are kind of shocked at how much work it takes to turn on or off one pixel, but that's it. That's the reality. If you work in a very low level, in the level of bits, that's what you have to do in order to control the screen. Now, I didn't work out all the algebra.
It's also a 256 by 512 screen, so it's a tiny screen compared to like 1024 screens that we have these days.
That you're going to access the right bit in the memory.
Want to change the bit in row 4, column 55. Should you retrieve, what address should you retrieve? Which bit should you change? I mean, I've done it already, but it's it would be 32 times row plus column divided by 16. That would be screen. And then it would be
that 1 and 3, the value and writing the value back are
I don't know why I'm sleepy suddenly.
RAM operations, read, write, and we discussed it before when we talked about memory units in general. Okay, now I also want to give you an example of how this thing actually works inside our hardware simulator. So I'd like to load the screen chip into the hardware memory, manipulate it, and you can see in your own eyes how it's going to actually change the screen and manipulate the pixels. So let us load the built-in screen.
Why's my microphone picking up a child speaking outside?
Loaded it. I can inspect the HDL code and see that indeed the screen chip is a built-in chip, and it's a memory chip. And if I look at the input pins and the output pins, I see that it has the typical memory chip interface. It has an in input, an out output, a load bit that must be asserted before write operations, and it has an address that enables me to select the register on which I want to operate. Another thing that we can observe is that the screen built-in chip has a GUI side effect.
I kind of just need to copy notepad. Kind of just need to copy the formula he gave me a little bit ago. Yeah, that formula. So it is screen 32 plus row. And then it's a plus, yeah, 32 multiplied by row. 32 multiplied by row plus column divided by 16, or inside RAM it would be the same thing, but it'd be 16,384 plus 32 multiplied by row plus column divided by 16. I've been doing touch typing practice, but I still, when numbers get involved, I still suck at touch typing because I haven't been taught how to do numbers, like which finger goes on which number yet.
In the fourth row and in column number 55. Work out the numbers and convince yourself that you're going to access the right bit in the memory.
Why am I sleepy suddenly? I should make some coffee or something. Yeah, we just did this.
Once again, I want to emphasize that 1 and 3, the fetching the value and writing the value back, are regular RAM operations, read, write, and we discussed it before when we talked about memory units in general. It works inside hardware memory, the built-in screen chip. So we look for a screen, and here it is. Loaded it. I can inspect the HDL code and see that indeed the screen chip is a built-in pins on the output, input and outputs, and it has it. Another thing that we can observe is that the screen built-in chip has a GUI side effect, which is this panel here, which represents or simulates a physical screen consisting of 512 columns and rows is represented in the lecture. The first 3 to black. So in order to do this, we have to get to the register that represents the first 16 bits in row number 3. So we do 32 times 3, which gives us 96. This is the address that we have to make. So we write 96 in the address input. We assert the load bit because we're going to write something into the memory, and we have to write 1111 16 times, and it turns out that 1111 16 times in decimal, and 2's complement is -1. If you're not convinced, we can turn the representation to binary, and we see that indeed we got 16 ones. Let's turn it back into decimal, which is easier to read, and we see that it's very nice that we entered all these values into the memory, but we haven't ran the clock, so nothing really happened. This is a memory device, so let's run the clock. And we see that once we run it, we get two things happen. First of all, the memory now contains this value in address number 96, but also we have the side effect of seeing 16 black pixels at the beginning of row number 3 in the physical screen. Now, let us write some other arbitrary value in some other arbitrary address in the screen. So we go to the address input, we pick up some arbitrary address like 3035, and let's pick up some arbitrary value like 17 that we want to write into this address. And I'm not sure how many ones we have in 17. Let's turn the binary on, and we see that we have only 2 ones, so this is not going to be extremely visible. But in any rate, let's run the clock. And indeed, we see that these 2 babies popped up right in the middle of some obscure screen location, which happens to correspond to the register that we manipulated in the screen memory. So these 2 pixels obviously correspond to the 2 ones that happen to be the only 2 1 bits in the binary representation of 17. So this has been a demo of manipulating the physical screen using the respective memory map, the screen chip that controls it. So the next thing that I want to talk about is the input unit. How do we control and manipulate the keyboard? Well, the physical keyboard is connected to the computer using a
How am I gonna
if you will
get rid of them?
You will see that it goes into an area in the RAM which is called keyboard memory map. Just like we had a screen memory map, we also have a keyboard memory map, and this is the representative of the keyboard inside the computer architecture. Now, it turns out that in order to represent the keyboard, you don't need more than 16 bits. So the keyboard memory map is a single register, 16-bit register, which is called keyboard. And this is how the connection works. We have a special chip called keyboard, which once again is simply a 16-bit register. And in the next few minutes, I'm going to describe how this thing actually works. So we'll do it using examples. When a key is pressed on the keyboard, the key's scan code, which is an agreed upon value, travels through the cable and appears in the keyboard memory map. For example, if I press K, there is an agreed upon value, which happens to be 75, completely, well, not exactly, but almost an arbitrary value. And this value, 75, is going to appear in its binary manifestation in the keyboard chip. All right, I take my finger off and I click something else, like 4. Well, 4, it's true that it's a number, but on the keyboard it's yet another symbol. So the scan code of 4 happens to be 52. So if I click 4, I see the number 52 appearing in the keyboard memory map. If I click space, well, space is yet another symbol. I see the number 32 appearing there. If I click up arrow, it's yet another symbol. I see the number 131, and so on and so forth. Every key on the keyboard has a scan key which represents this selection inside the computer using a binary code. All right, so what we have here is the complete character set of the hack computer. These are the keys that the hack computer recognizes. It's a subset of the keys that you have on your regular keyboard, but it's sufficiently rich subset for our own purposes. Obviously, we could have represented all the other keys, but we decided to represent the subset of keys only. And by the way, if you have 16 bits, you can represent numerous keys and letters in many different languages. And
I was not paying attention. Okay, hold on.
Memory map is a single register, 16-bit register, which is called keyboard. And this is how the connection works. We have a special chip called keyboard, which once again is simply a 16-bit register. And in the next
where is it though in the RAM?
So we'll do it using examples.
Where is it in the
when
RAM?
a key is pressed on the keyboard, the key's scan code, which is an agreed upon value, travels through the cable and appears in the keyboard memory map. For example, if I press K, there is an agreed upon value, which happens to be 75, completely, well, not exactly, but almost an arbitrary value. And this value, 75, is going to appear in its binary manifestation in the keyboard chip. All right, I take my finger off and I click something else, like 4. Well, 4, it's true that it's a number, but on the keyboard it's yet another symbol.
What is 0?
So the scan code of 4 happens to be 52.
Like
so
what?
If I click 4,
like I need to know what means no key is pressed, which I'm assuming is 0, and then if any key is pressed, which would be probably greater than 0, is what I'm assuming. But what if no key is pressed is something else? Like what if it's like a -1 or something? That is something I need to know, which he's not telling me.
I see the number 52 appearing in the keyboard memory map. If I click space, well, space is yet another symbol. I see the number 32 appearing there. If I click up arrow, it's yet another symbol. I see the number 131, and so on and so forth. Every key on the keyboard has a scan key which represents this selection inside the computer using a binary code. All right, so what we have here is the complete character set of the hack computer. These are the keys that the hack computer recognizes. It's a subset of the keys that you have on your regular.
When no key is pressed, the resulting code is 0. Okay,
but it's
great.
sufficiently rich subset for our own purposes. Obviously, we could have represented all the other keys, but we decided to represent the subset of keys only. And by the way, if you have 16 bits, you can represent numerous keys. And,
Once we're done with like this, I wanna try and build a computer in like Core Keeper, which is a game that's like coming out, although I've owned it in early access for like 3 years at this point. I need to beat it as well, but I also like want to try and do it in like an actual assembly language, because this is like a made-up assembly language to teach you about assembly languages. I mean, I have plans. Not all of them might be turned into content, but I'm always working on something, so I have plans.
And the letters in many different languages, and it's more than enough. Those of you who are familiar with the notion of Unicode or ASCII can make the connection between these notions and what we do here. It's essentially the very same idea. And by the way, when you don't touch the keyboard, when the keyboard is idle, the number that we see in the memory map is 0. So that's how we can tell if the keyboard is actually being used. The memory map, once again, is this 16-bit register. And if you want to check if which key is currently pressed, all we have to do is probe the contents of the keyboard chip. In the head computer, we probe the contents of RAM in address 24576 because this is where the keyboard memory map happens to reside. That is, when we're going to build the overall computer, we'll do it next week.
So the probe of the contents of the keyboard chip in hack computer probe the content of RAM 24576. So keyboard. Wow, I suck. Okay, let's try that again. Keyboard is RAM. Jesus, why am I so bad suddenly? RAM, not ramp. RAM 24576. All right.
To connect several chips together, we're going to begin with some regular memory units, and then we're going to add to it the screen memory chip, and finally we're going to add the keyboard. And the keyboard in this overall address space is going to be located in address 24576. So if I want to know if someone is pressing the keyboard, I have to look up the value of this particular memory register. If it contains 0, no key is pressed. If the register contains some other number, well, I can tell which key was pressed.
And any key is pressed. That's how. You know what? I think the most efficient way to detect if any key is pressed is literally just do it in assembly. I guess doing it in C would be the same thing because you could go check the key code in C, but I don't know if you can do it in something like a Python or a C# or something, which is usually what people use for game dev. Just saying. Or GDScript. Although GDScript you can like go back down to like a C++ or a C, but at that point you're not really doing like Godot game dev, you're more doing engine dev. I don't know, I need to look into how Godot works, man. I need to make a game in Godot as well. I also need to look into how Godot freaking works, like just like what's happening under there. Like I never needed to know in Unity, and also Unity doesn't tell you, but because Godot tells you, I kind of want to, you know, go take a peek. I feel like Bevy is something I want to look into at some point too. Although Bevy's Rust, right? Yeah, Bevy's Rust. Is there like a C game engine? Is there like a straight up C game engine? Looking for a game engine programmable in C. It has GUI editor like Godot. Oryx, this is from 3 years ago. The machinery. In actual C, full game engine, open source. IO Quake. It's the Quake engine written in C. I don't know why, but I feel like C, a game engine in C would be so great. Pop, how about like popular C game engine? This is again 2 years ago. How much is C used for game dev? I mean, you can use it for everything. That's the thing. List of C game engines. List of game engines. Top 24. I mean, C++, Unreal. Just saying. But what about C? What about C? Is C an acceptable language mode? I mean, it is. It should be, but apparently not. Apparently, there's no game engine. Like, game dev in C. Like, I guess SDL, right? CS per SDL isn't an engine, but we'll do the. I mean, you at that point, like, if you're doing game dev in C, I guess at that point you just roll your own engine because you're doing C. I don't know.
Give you a demonstration of how your physical keyboard is connected to the head computer through this keyboard memory map. So that's what we'll do next. Let us load the built-in keyboard chip, and here it is. Let's take a look at the HDL code, and we see that indeed keyboard is a built-in chip. And if we look at the chip interface, we see that it's a read-only chip. It has no input pins at all. It has only one output, which emits the value that is currently stored in the keyboard chip. Now, this keyboard chip also has a side effect, which is that the keyboard chip is connected to the actual keyboard that I'm using on my computer, on my real computer. And so will be the setting at your end. If you use a hardware simulator, the hardware simulator is connected to your physical regular keyboard. And if you touch the keyboard, if you press any key on the keyboard, the scan code of this key is going to be
But which key is the any key?
Built-in keyboard chip. So let us test this. And I'm taking my finger now, and I'm pressing the key G, and nothing happens. Well, nothing happens because I have to enable the keyboard, so I do it by clicking this button here. So now let us click G, and I'm holding my finger down, And as long as I hold my finger down, I will see the scan code of G, which happens to be 71, emitted by the built-in keyboard chip, which acts as the keyboard memory map. So I'm lifting my finger now, and as you see, the keyboard chip now emits the value 0, which means that none of the keys on the keyboard are presently pressed. Let's try another key. I'm going to press space. So pressing space, and I see that the scan code of space, which happens to be 32, appears. Let me press down arrow, and down arrow happens to be 133. Let us press a digit, say 8, and 8 happens to be associated with a scan code of 56, and so on and so forth. So this has been a demonstration of how we can figure out which key the user is currently pressing on the keyboard. And once again, recall that if the user is not pressing anything, we're going to see 0. So this has been the unit in which we broadened our perspective, so to speak, and added input-output units to the computer. And the most important part of this unit was to give you an idea of how you, as a programmer, can actually control these input-output units.
I bet. Okay, that helps me a little bit, I guess. I just need to figure out how to make this screen go black, right? Where's the thing I'm actually supposed to be working on? It's right here. So what I need to do is, what does this guy do? So it goes to RAM 0, it copies it into D, then it goes to RAM 23, I don't know why, but it does do, no, it goes to around 16, goes here, goes to around 16, well, first it goes to 23, then it just checks if D is, what is JLE again? What does JLE mean again? Hold on. Let me just do the thing on this screen. org.org. Okay, hold on. We're gonna open up the freaking PowerPoint that tells me stuff. Also shows me pictures of old people, including Alan Turing and Ada Lovelace, early symbolic programming, and Alan Turing, who made the first computer, basically, and John von Neumann. It sounds like a name of a singer, to be fair. I feel like Von Neumann is a great Hollywood name. Anyways, what is the freaking thing? The JLE. Okay, here we are. JLE means if D is less than or equal to 0. So if D, which 48 for us would be, go to 23, so it's not less than or equal to 0. So we continue, we go to 16, we copy D into 16. How about I just hold on, we'll just step through it. So it's not, so we don't go there, we go to 16, we copy 48 into 16, then we go into the screen one, right? Then we go into the screen one, we do D is equal to A, so we put D, we copy the value of A, which is this value, into D, right? Then we come back to 17, we copy that value over here, then we copy A into M. So at 17, we copy A into M, and then M was copied there. Hold up. So you go to 17, we went to this value, we copied that value, we just stored that value, we came back to 17, we put that value into 17, and then we also put that value into A, then we said -1 from that value, come back to 17, copy it into D, go to 32, add that back to, I don't know what's going on now at this point. Why are we doing all these things is what I'm trying to wonder. And then MD is equal to, what is MD? What does MD do? I don't know what that does, to be fair. I don't know, literally MD. It doesn't mean both M and D is going to be equal to M-1. And then at 10, I'm so confused. So -1 just means like draw a line, right? But like, what is 17 being used for? Is what I'm trying to figure out. What is 17 being used for? I guess it's not helping at all. It's not helping. What if I just wanted to draw a line at 16,384, which is, you know, the topmost thing. I just want to draw a line there. How would I go about it? That's what I'm trying to figure out. Just got distracted from my phone as well. Bloop, deep bloop, deep bloop. I should just make some coffee. I'm just getting sleepy. EP. Okay, let's open up a new here. Actually, no, I'm gonna do code. Do it in VS Code. I know VS Code is not is like cringe at this point. I know, don't at me, I know. But sometimes you just gotta VS Code, man. Sometimes you just gotta VS Code. Where is the thing that I'm trying to do here? Great. Yeah, I trust the author. Since the author is me, new file, we're gonna call it fill.asm. Call it fill.asm. And then I'm gonna figure out how. So if I just want to draw a straight line at 16,384, right? 16,384. I just want to draw a straight line. So again, 32 times 0 and 0 divides it just be plus 0 plus 0, basically plus 0 plus 0. And then I set RAM. I basically need to set at 16,384. I just need to set M to -1, right? That's all I need to do to draw a line at the top left corner of the screen, I think. At least that's what he's told me. So if I just do that, and if I just load that from local, if I just load that, and if I just step through that, that makes a line there. Is there a way that I can just make the entire screen go black? Right? How many what was the limits? What were the limits that he told me about? Cause let's say, what's the theoretical limit here? What is the limit here that I can get to? What it's like, it's 256 by 512, right? So if I do 256, I think I'm doing it the opposite because there's more rows than columns. Let me just do that. Let me just try that out. So 32 into 256 plus 512 divided by 16, 24,608. What happens if I do that? 24,608. Does anything happen if I do that? Nothing happens when I do that. Hold up. Reset. Step. Yeah, no, nothing happens if I do that. So turn that around. 512 and 256 or 255 actually. It's probably 511 and 255. Let me just go double check real quick. We're gonna make a duplicate of this because I still need to have my jump instructions in front of me. And just go check what the input output are. If it freaking loads, which doesn't want to load sometimes, it's gonna download the PDF so that it lets me do the thing. Okay. Please load. Please don't crash my PC while trying to load a freaking PDF as well. It's a 151 page PDF. Like, it shouldn't take this long. Either way. Come on. Okay. I'm gonna have to go through this slowly. Do 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 do. Right. Oh, where's my music? Forgot I was playing music. There we go. Hopefully it's not too loud. Do do. Program translation. I don't need to know about that right now. All I want to know is pointer-based processing, array processing. I just want input output. Input output, right? Input output. There we go. So it goes from, what it's telling me is the screen goes from 16,384 all the way to 24,575, which and then 24,576 is where the keyboard starts. Okay, so up until there is where I need to go. So that is 24,575 not 25, 24,575 minus 16,384. I need a loop that adds 1 all the way up to 8191. Is there a faster way to do this though? An 8K, yeah, it's an 8K memory block basically. Dedicated to black and white display unit, base address screen. Okay, output is rendered by writing bits in the screen map. That's great. All I'm thinking is, how can I just like make it black entirely? How do I just make it black entirely? That's what I'm thinking. So rows, by the way, sorry, columns go up to 511. Columns go up to 511. And rows go up to 255. So yeah, so row 255 max. That's how it should write it, and then 511 max. Columns. That's what my formula needs to be. Also, using mathematical symbols is not great inside a mathematical formula to represent things. Like, you should write them as notes below. Just, this is math. Yeah. I'll figure out how to do a loop. I mean, I know how to do a loop, but like, examples of simple patterns that can be drawn relatively easy. Oh, it says I can do add screen. Okay, can I just do add screen? M equals -1, so reset. Oh, wait. At screen. That's not a thing. It says I can do it, but apparently not. Or maybe it's like add screen. Still not a thing. It says I can do it, but it doesn't let me do it. Right. How do I like reset the screen here? I don't know how to reset the screen there. It's there's a line up there that I want to remove. I guess I can just like set it 16,384. I can just set to 0. 16. It's 384. It's correct. 16,384. We can just set it to 0 real quick. Equals 0. Okay, and then when I step in, it's gone. Great. Bitmaps. I don't need the bitmap stuff. I just need the screen. Output. Binary output project 4. That's the hack character set. We don't need any of that. I just wanna turn the screen black. Right? I just wanna turn, I mean I can. I'm just thinking that, like, I don't wanna do a loop that's that big. Like, is there a faster way? I'm gonna go look at like the arrays and stuff that I skipped earlier. That was telling me about, because I'm a dum-dum. My dum-dum want gum-gum. It does say something like that, right? Like, can I create an array that's this big and set all values to 1 and then copy it over? Like, that's what I'm thinking. Do 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 do. Do 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 do. Pointer demo. Starting at address stored in R0 sets the first R1 words to -1. So loop and end essentially is how they want to go about it. So at m is equal to 0. Okay, at I, d is equal to m, r1 equal d minus 1, and then j equals 0. JEQ means if j equals 0, jump to end, otherwise r0, d is equal to m, a is equal to d plus m, m is equal to -1. We could use this loop. Go to loop, and then goes back up to loop. We can use this loop. By the way, I'm going to show you what I'm looking at. I'm looking at this. I feel like I should go make some coffee, because I need to rack my brain at this. I feel like we can use that loop, though. We can use that loop and then start at 16,384. Go all the way up to, 81, 91. Or R is equal to 224,575 essentially, and set it all black. Paint it black. You see a red door, you paint it black. And then once figure out the input thing so that the loop only runs if a key is pressed, and then if the key is not pressed, you don't run the loop, and then you run another loop which sets the entire screen white. I feel like that's what we need to do, but just gotta do it now. But before that, I'm gonna BRB, and I'm gonna make myself some coffee. So BRB. Somebody dropped something outside. Hey, we're back. We're back with some coffee. I have coffee now. I spilled a little bit of it, but I have coffee now. It says, happy homeschool. A school I did not go to, but I have a mug from it for it. Probably because my mom was given a mug for it. But anyways, I don't know how you guys have your coffee. I used to. This is a week, like this is a development that happened this week, basically. Is that I used to really love having black coffee. I'm still kind of used to just black coffee, by the way, because I was told that if you get really used to having black coffee, you'll never really need anything else apart from coffee to have coffee, you know? All you need is coffee and hot water. But then recently I learned that if you're just having black coffee, it very easily stains your teeth. So now I've been adding like milk and creamer and shit to my coffee whenever I can, because, you know, my teeth are bad enough already. I don't want them to be stained as well. It is hot though. It is hot. It do be hot. Right, let's figure this out. Let's figure out how to make the screen go black before we do anything else. So what I want to do is inside VS Code, what I want to do is I want to do what they've done, is just copy the, so like at I m is equal, god damn it, stop pressing that key. Okay, m is equal to 0 at I. Starting at the address stored in R0 sets the first R1 words to -1, right? So the address stored in R0 for us, so we're just gonna do address. Also, did I drop frames there? No, I seem to still be live. It seems to still be fine. So address in R0 should be 16.384, and in R1 should be 8191, right? 8191 words to -1. That's what we want to do. So then just go through this loop, and at I we want to set D to M, so basically setting D to 0, and then at R1 we're gonna set D equals D minus M, which would just be, you know, with the 0 minus 0 for the first loop basically, and end, go to the end if D equals 0, right? Now here we want basically R0 plus I equals -1. That's what we want to do? Huh? I don't quite understand. What, like, R0 plus I, oh, as in like RAM, so the thing inside RAM 0 plus I, so RAM 0 is the starting position and I is the current position, which at this point would be 0 because I is 0, and then we want to set it to -1. That's what we're doing. So R0, we set D to M, and then at I, if we set D to M, D is equal to, wait, at R1, D is equal to D minus M. R1 tells us the final value, right? The final value. So if we do D equals D minus M, that's 0 minus the final value. So D gets set to the final value at R1, right? And if D is not set to 0, we go to N, so we don't go to N there. Then we come back to R0, we copy the value in R0, which is basically the the starting value, right? We go to that starting value and we copy it into D, right? And then we go back to our I, which is also just a variable that we've assigned. And then we say A equals D plus M. So at this point, D is the starting value, and M is what I currently is, right? So D is the starting value, M is what I currently is, and then we can do M is equal to -1. Okay, so what A is basically, A is the address. So if it's like, so M is basically RAM A, where A is the address and M is the value in that address. So when we want to change the value inside that address, we do M equals something. But when we do A, we say the address. So D is the starting address currently. We go to I, we essentially get the variable I that we want, so that like M equals that variable's value, which we've set to 0 here, and it's currently just the first loop, so it is currently 0. And then D is currently set to the value of R0, which R0 means this. It's the RAM 0 value essentially. R0, which is the starting value for us, which is going to be set to this. So D plus M is basically that value plus 0, which is what we're saying that like, okay, so select this address, whatever this address is, right? And for us, this address is the starting address. And then we're saying at that address, set the value of that address to -1. So we're creating a black bar at that address. Great. And then we just need to do I equals I plus 1. So that we increment the loop. So we go to at I and we can just do M equals M plus 1. And then we go back to loop, I guess. Go back to loop. Just jump to loop if 0 is equal to 0. So just jump there. And then they have something like this. Like this is the example they've given for a loop, by the way. And this is at end 0. So it just goes like jumps back and forth if we get to this point, right? So from here, if we jump to at end, which I'm assuming is this, and so that's what we're defining as end, it'll just, it'll just keep jumping back and forth if it gets to here. So let's see if we can make the entire screen black. We can see a white screen and paint it black with just that code. Select local file, fill. Okay. Why did I get set to 16? Does I just get set to 16? I guess I just get set to 16. Strange. Yeah, I suppose I get set to 16, and then so 16, 17. I'm assuming these memory addresses are reserved for like any variables that you define yourself. That's why like loop became 17 and I became 16. But then loop also became 16. Yeah, loop and I both became 16, and it says at 2 JMP because it's supposed to jump into the second line, and then second. I'm so confused. When we're defining lines, we define them as these, I guess. So this line is called loop, and the line is line number 2. So that's why I'm saying at number 2, go to that line and 0 jump. All right, it kind of makes sense. It makes sense in my head. It's hard to explain, so I'm sorry. It's also assembly code. So it's pretty hard to... Have you always had a passion for this work, or did you struggle to get into it at all. I have always, hey Scapegoat, sup? We doing assembly code, which is really hard to wrap your head around. And also Nice Cam asked if I have always had a passion for this work. I've had a passion to learn about how things work. I do struggle with it though. As you can see, I struggle with it. But thank you for asking. Also, I am seeing that is Streamlabs working, because I feel like the Streamlabs chat thing didn't show me either of those messages. Let me just do like a test. Does it work? It doesn't show me YouTube. That's strange. It was working before, but now it doesn't. Maybe I need to refresh. Maybe that's the thing. Like it needs to just refresh. I don't know how to refresh this page, to be fair. Okay, now it's just broken. So I gotta pop out YouTube chat. You are Scapegoat. I know you are Scapegoat. It says you are Scapegoat. But it's like, is it popping up on screen when you say that? Yeah, it does pop up on screen. I can see it pop up on screen. It just doesn't show it to me in my dashboard. So I need to like pop out YouTube chat and basically have it be open in a corner so I can actually see when people message in YouTube chat. Because otherwise I miss messages, which is sad. But yeah, if y'all new here, subscribe. We have YouTube videos. I recorded one today too. That'll be out. Also, I like probably gonna cut down bits from streams and put them in videos as well. Also live on Twitch at the same time. Cause yee. Anyways, let's see if we can make the screen actually go black. So our starting address, our starting memory address is 16,384. 16,384 is the starting memory address, and I want to go up until, it's going to be a really long loop, 8191. So for 81, we're going to try 8190. Well, let me just try like 100, basically. And then just run. Okay. Can I make it faster? Hold up, pause. Let's make you faster. Okay, so pause. That's 100. That's 100 pixels, all black. So it works, kind of. So if I do 8191, and then run. Reset. So far it's like at the same spots that it's already hit. If I make it, there we go. Okay, so the whole screen goes black. What about 8190 though? It should be the same thing. It shouldn't be the same thing. First of all, we're gonna have to reset, and we're gonna have to set it to m equals 0, so that the screen goes white again. So first we should do that, and then it leaves. Okay, so 8190, it actually leaves the final thing because it doesn't cover the entire thing. So it has to be 8191, and then m has to be -1, essentially. So all we really need to do now is detect that any key is being pressed, and basically just change, either do m-1 or m+1 based on any key being pressed, essentially. Pause, reset, and then just, yeah, there we go. I just need to go read the guidelines on if that is all I need to do. By the way, I don't know if anyone's on the YouTube mobile app, but if you are, when I say subscribe, does the subscribe button light up? And when I say like, does the like button light up? Because I don't know if that's just a thing that happens for partners, but I do know it's a thing that happens now, which is really cool. Because every time like I'm watching something, even though I'm already subscribed to someone, I'm like, yo, they said like and they said subscribe. And it lit up. It's really cool. But that also means like YouTube is listening at all times. But it's kind of cool. You know, it's kind of cool. It's kind of cool and scary, but also cool. Yeah. Ooh. Okay, how do we detect any key being pressed? So keyboard is, the value is like 24576 basically. So RAM value 24576. If that is set to anything above 0, any key is being pressed on the keyboard. So we just need to check if any key is being pressed and set the thing to 0. Otherwise, set it to 1. I'm gonna make it like, literally, I'm gonna write this code inefficiently because it's already freaking assembly. I feel like there's ways to optimize it, but I can also do it inefficiently because it's already assembly and I'm working directly with memory values. I feel like it's efficient enough, right? I feel like we're directly working with memory. The more efficient, like, we can only get so efficient if we were like working with like direct electrical signals, which technically we are, because that's what RAM is. RAM is electrical signals. But yeah, like, I can be inefficient right now just to get it done. We figure out efficiency stuff when we're like actually assembling the assembly language into like a freaking like a low level language or something. No, an assembler does the opposite. Assembler turns assembly into machine code, which is like zeros and ones. The opposite thing. What is the opposite thing? It's not a linker. It's a compiler. A compiler turns low-level code into assembly code, and then an assembler turns that assembly code into freaking zeros and ones that the computer understands. And the computer takes those zeros and ones and it goes like, this electrical signal is a 0 and this electrical signal is a 1, and somehow magic happens. Yeah. That is computer architecture 101. Kinda. Look at my start bar just being weird right now. It's because of VS Code not being below the start bar. It's also a freaking Linux Mint thing. Okay, so what we want to detect, essentially, hey Hassan, I read your message earlier, but I was just like, you know, in a brain rot loop there, a brain rot assembly loop, so I kind of just like forgot to respond. But how you doing? What is up? I'm assuming you're also from IGDA, since Discord today is picking up that I'm streaming on YouTube instead of streaming on Twitch, which is that's honestly the first time that's happened. Usually Discord shows that I'm streaming on Twitch instead of YouTube. Technically streaming on both though. I feel like I'm stuck in a loop right now. I need to actually do stuff. So I need to go to at 24576, right? And I need to look at the value inside. I need to copy the value inside here into D, and then I need to jump back to loop. No, I need to jump back to loop. I see. Nothing much, thanks for asking. And no, I ain't from Discord? Oh, you aren't from Discord? Did you just find me? How'd you find the stream? Did it get suggested to you? Because that's really cool if it did. It gets suggested to you? How you doing though? What you up to? Do you like all this stuff? Well, I'm doing this with my hand, but it's not on camera. I was saying, do you like doing all this stuff? Yeah. Okay, so I copy that into D, and then where do I want to jump? If any key is being pressed, I want to jump inside loop, or do I want to jump yeah, if any key is being pressed, I jump into the loop. Otherwise, I set the screen white. So I can just, like, doing this inefficiently first, I can just so this is not, like, this can be, but, like, end is gonna be weird. Okay, hold on. I gotta put this over here. And then we need something that sets it to white, right? We need something that sets it to white. Yep, I was suggested. I was watching a coding lecture, so this suddenly was recommended to me, and I would be learning assembly language this semester. So I thought, this is technically not real assembly language, by the way. I mean, it is, but it's a made-up assembly language for a virtual computer. Like, this is a virtual computer that I'm coding on right now. Actual assembly language, like Z86 assembly, x86, Z80, right? x86 assembly, is a lot easier to understand, I would say. Right now, like, this is because this is literally a 16-bit virtual computer that I'm coding on. Like, I'm more restricted than, like, actual x86 assembly, which has way more things that you can do, essentially. There's a lot more you can do in like an x86 architecture. I think x86 is the one that, like, is the most used, but, like, there's more assembly languages. Hold up, assembly languages. Just Wikipedia, please. It doesn't give me a list, but I think the most widely used thing is x86. There's obviously others. The best thing is that all assembly languages can just directly, you know, be written, like, just directly be converted into C code. So C run, like, literally, you guys don't know, when C came out, it was so revolutionary because C ran everywhere. And I feel like since then, people have forgot that C can still run everywhere, and people just keep trying to make new languages to run on specific things. Like, why the fuck can't you just run C on iPhones? Why do I need to buy an Apple computer to write in Xcode and write in a C-like language when I should just be able to write C directly on the iPhone, right? Or an Android or whatever. Like, C still does that. Like, you can still do that in C, but so many companies don't want you to anymore because they want you to use their own thing and then pay for that. But yeah, C is revolutionary because C ran on it. Like, literally at this point, like, because of so many different types of assembly languages, and because there was no standard, like, the size of an integer or the size of a word or the size of a float would be variable in different architectures. Like, it wouldn't just be like a 16-bit integer. Something might have a 48-bit integer. Something might have like a 2-bit integer. I don't know how you make a 2-bit integer. That's not a thing that's actually possible. But anyways, once, like, somebody figured out that no, we need standard stuff so that we can have standard assembly code, so that we can have a language that can run anywhere, and C was that freaking language. I mean, C++ started off as a subsidy, like, as a add-on to C. They're completely different languages now, but, like, initially that's how it started. But yeah, C is magical. C is really magical. I don't know. I feel like all programming is magical, and I'm just trying to decipher the magic. But yeah, good luck. Can I still learn it? Yeah, you can still learn it. I feel like knowing something like a Python or something, or anything else, really. Any programming language lets you learn other programming languages pretty easily. Like, once you know one, it's really easy to pick up, like, a second or a third or whatever. Like, technically, I don't code in C or Python very often. Like, the thing I code in most often is C#, right? Because like, Unity development, or GD script now. But I still like I can still say like I know C or I know Python because I can just kind of go look up the syntax and do something if I need to. I also don't really code in JavaScript, but if I wanted to make something, I could probably go do it in JavaScript, right? So I think you can learn any language at this point. Like if you know a language, it's pretty easy to like be a polyglot. Yeah, I mean, you did things even though you're not a programmer, or you didn't title yourself a programmer, but you were able to figure stuff out, right? Because I feel like once you know one thing, you can kind of like it feels like it's transferable. I mean, C++ is great. You can do a lot in C++. You can do pretty much everything you can do in C and C++. Like, you can do anything in any language, to be fair. It's just that C is, like, a lot of the time C, like, the code from C can be directly converted to code in assembly. Like, you can see what C is doing in straight up assembly and the things it's calling. With Python, with something like Python, that's not directly possible because, like, for Python, there's a bunch of other instructions that get called, and then the actual Python code gets called to run like a Python script. So if you wanted to see what Python is doing in assembly, a bunch of other stuff, which is a lot of like C code, by the way, because Python is just like a little, like, you know how when you're a kid and you don't know how to write, so you're given a stencil that you can put on top of the paper so that you can, like, you know, trace A and B and C. Python is basically that on top of C, right? So Python essentially calls C code, which calls assembly code to do stuff. So it's like a wrapper on top of C. That's what Python mostly is. But it's still a great language, though. What's your target for the stream, learning or making something? Right now, I'm trying to do this project. My target for this stream is I'm just trying to get consistent with streaming again. I used to stream a ton. Basically, like 3 years ago, I used to stream a ton. That's why if you go on my Twitch, like, there's a bunch of following. Like, I have a following on Twitch, but I'm trying to just be consistent again with streaming. So I'm just trying to, like, whatever I'm working on, I just want to stream it, and then eventually we might have goals and stuff. Although I have a ton of stuff that's like, here, look at my list of things I need to do, including dishes and folding laundry and getting water and fixing a power adapter. Those are chores. Gramps is the company I work on that I need to do stuff. This currently what we're doing right now is this is what we're doing. We're doing fill.asm. Can I have the Discord link though? IGDA Discord is a Discord I'm a moderator in. That's like an IGDA thing, but I have a personal Discord. I can give you the link of that if you want to join. It's kind of dead though. I don't know. I'll just link it. Although if you expand my you're on YouTube, right? So it's actually in the description. Like the link to my personal Discord should be in the description of the YouTube video. I don't know how you open that during a live stream, to be honest. I'll just get you it. Nice chores, not gonna lie. I've only done laundry so far for today. But yeah, this is all the stuff I need to do. So technically this is just a work with me stream. I think that's what if you saw the thumbnail on the YouTube stream, that's what the thumbnail said. It said work with me. Let me get you my personal Discord link. Although if you're from Pakistan, I can also get you the IGDA PK Discord link. Hold up. Doobie not server settings. I'll do invite, copy the link and post it into YouTube chat. There we go. Hopefully that works. I don't know. It might not. Boom, 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 boom. Oh, you are? Okay, then let me get you the IGDA PK Discord link as well. It's a Discord full of game developers that we are trying to get more active. So I would love if more people would join. Invite people, copy link, paste that there. Damn. Sorry, from Jimmy Vegas. I don't know who that is. I started from freaking Brackies, when Brackies posted their like first or second ever video. Like I remember watching Brackies when the video was new and uploaded like a week ago. That's how I learned Unity technically, but like I didn't actually make anything in Unity for a really long time. I think I actually started like actually doing stuff very recently. For a really long time I used to just like try stuff out and not actually do it. Yeah, whatever. I do have a YouTube video talking about how much I've done, like how far back my game dev stuff goes, because technically I started in Atari Light C when I was like 7 or 8, but never actually made anything in it. Then I went on to RPG Maker, tried to make a bunch of Pokemon games, never finished those. Eventually found Unity, did nothing with it. Did some Flash games, but again, never really went anywhere. Although I recently opened up Newgrounds, and my Flash games actually, like, they still get traction. Like, to this day, I have like 4 Flash games on there. They still get seen by people. They're not great, but they still get seen. Yeah, Newgrounds used to pay you. I wish they still did, because those Flash games have a lot of views. But yeah, saying I've done a bunch. Just until recently though is when I actually got serious about things and started like actually upskilling and being better about things, because before I used to just bleh. There's a YouTube video about, like, on my channel there is a video about this. I don't remember what the channel is. Bloop. Yeah. Scapegoat is Hamza, right? Are you okay with me saying your real name, by the way? I'm sorry, I just said it out loud. But yeah, okay, what was I trying to do? I'm trying to figure out at 24576, if any key is being pressed, where do I want to go? I want to go into, I guess if any key is, I need to make another loop. Wow, people just be joining my Discord. I need to make it so that there is a loop. Let me just copy this, right? Let me just copy this and call it white loop, right? Call it white loop, and like white end, which sounds like I'm about to end racism, but not really. It's just assembly. Yeah. And then end, white end should be down here. White end should be down here. Yeah. So you jump to loop yeah, so I want to jump to white loop, essentially. White loop. I want to jump to white loop if D is equal to 0, I want to jump to white loop. Otherwise, I want to continue. Right? We're gonna have to also, inside white end, we're gonna also have to find a different variable that's not I. So yeah, we're gonna have to call this J, and J, and anywhere else that I mentioned I just gonna do J, and basically set it to 0. This is a very inefficient way of doing this, but I just want to see if it works, and then we can figure out how to do it with just one loop. Making your entire computer go through 2 loops, 2 nested loops in assembly is pretty inefficient, just by the way, even though we are coding in assembly. But so what will happen is it'll get here, and then it'll just like start looping here. I don't want it to start looping here. I want it to go back to 0. So I just want it to go back to 0. Once it gets to here, I want it to go back to 0, right? Also, jump to white loop here. Jump to white loop here, right? Yeah, jump to white loop here. Otherwise, yeah, the Roller Coaster Tycoon dev is a GOAT. You know why he's also a GOAT? I don't know if you guys realize this, but like when I'm writing to screen right now, I am having to write every single pixel. Like I'm having to set every single pixel to 1 on the screen, right? Go look at Roller Coaster Tycoon and how many colors and how many animations and how many just the sheer number of pixels that are on the screen on Roller Coaster Tycoon at the same time. And then imagine that dude programming those animations, those sprites, those pixels on the screen, pixel by pixel. Think about that, because that's what that dude did. That's why he the GOAT. Hold up. I need to play a clip. Wait. I this is a browser. I can just see. That's why he's the GOAT. Don't judge my. There. These are my feelings towards Roller Coaster Dev. It's the GOAT. Anyways. I feel like I never need to go to end, basically. Also white end. Yeah, I think I never need to go to end. Because if it goes into the end loop and I press a key, it needs to go back up. So I just need to go back to up, like back to 0 at all times. Nasser Gabelli. I don't know who that is. The programmer of Final Fantasy 1 to 3. Used to memorize the code he wrote in his head. I mean, to be fair, doesn't that happen automatically though? Like I feel like when I'm really deep in a project, I feel like I know where things are in that project. But yeah, it goes away after a while. This Nasser Gabelli dude looks so freaking gangster though. Like that is a gangster. Like this could be a GTA Vice City boss right here. If this is the actual guy, where like, I feel like this has to be the actual guy. I feel like people in the 70s just like knew what was up. He got like, this is probably a younger picture, so he's like more nervous here. But then he found his style, you know, he found his style and he turned into this. These look like two different people. I feel like I'm looking at a different person. Yeah, these are definitely two different people. I feel like this is the Final Fantasy guy. Who's this? Who's this? If that's not the Final Fantasy guy. Yeah, who is that? I'm sorry, it's more. Now I need to know who that is. The dude dropped out because he was not satisfied from his university curriculum. I wish I had the money to do that. The mustache one is a young. Oh, so it's the same guy, but this is younger, and that's older. Damn. Fair. Let's go look at his Wikipedia, I guess. He's Iranian or Iranian. Serious Software, Gabelli Software, Famicom, Final Fantasy, Secret. Oh, he's cool. Secret of Mana. Later Life, Legacy. He's probably still alive, right? I mean, oh, never mind. Okay, years active. Sorry. Yeah, he's still alive. He's just 67, but he's still alive. These are some hot games, though. And again, didn't make Final Fantasy until what? How many years? 7? No. When does it start? Yeah, 7 years into being a developer is when he essentially got his big break. I'm sure the other games were successful, but we don't talk about these games. We talk about these. Gotta make a bunch of games before you get that. You know the more fascinating list, to be fair, is this one. I know, I'm pretty there's like a really popular Pirate Software short about this. I'm sure you guys know about this already. Scott Cawthon is the creator of Five Nights at Freddy's. He started in 1994, has all of these games, and then Five Nights at Freddy's is like somewhere here. Wait, somewhere, not Flanville. Thought it's at FNAF. All of when did Five Nights at Freddy's come out? It's like 2010s, right? Where is it? 2014. Okay, so all of these games, and then somewhere in 2014, it's gonna say Five Nights at Freddy's. I still can't find it, to be fair. There's Fart Hotel though. That's usually when you look at like a game developer's freaking like discography. There's so much there. I mean, to be fair, it works with like everyone. Like even like music people, like they're making so much stuff. They're just not putting it all out. They're making so much stuff. Yeah, so Five Nights at Freddy's comes out in 2014. I can't find it on the actual like games list. I don't know why, unless this just non Five Nights at Freddy's video games. Okay. Literally that's what the list is, and I'm trying to find Five Nights at Freddy's there. Yeah. So again, all of these freaking games from 1994 up until 2014, 20 years of making games that maybe people heard of. I mean, I'm sure Metroid Ripped Worlds is something that fans of Metroid probably knew about, right? But still, 20 years of just making games that most people didn't know about, and then FNAF happens. How old is Scott Cawthon? I don't even know. Well, he's only 46. Damn. I mean, 46 is pretty old, but still, it's pretty young as well. Ooh. Sakauchi. Who is Sakauchi? I don't know a lot of people's names, to be fair. I'm very much like a Nintendo kid, so I know all the Nintendo people. I don't know a lot of other people. I mean, I guess I knew Tetsuya Nomura, just because, you know, Kingdom Hearts fandom. Also, I thought dude was young. He's pretty old at this point. Yeah, just because like Kingdom Hearts and Final Fantasy VII, which is like arguably what put Final Fantasy on the map. Anyways, let's go back to our assembly code. We got sidetracked a bunch. So what I need to do, well, let's just see if this runs, right? Let's just see if this runs. We need to see if it is not equal to 0, or if it is equal to 0, we go into white loop, otherwise we continue. And then here, instead of going to white end, we should just go back to 0, right? At the end of each loop, we should just go back to 0, but no, this should be white loop. Yeah, this should be white loop here. And then this white end thing. If D is JQ, it should go to 0, right? So we don't need to ever go to white end or end, right? It just loops and then goes back to 0 and checks if we need to go into white loop or if we need to continue here. So now all we need to do is check that D is greater than 0, which should be... Wait, we go into white loop if it is greater than 0. Yeah, if it is 0, then we don't go into... No, wait. I'm so confused. So if D is greater than 0, that means a key is being pressed, which means we need to go into the normal loop, so we don't jump. But if it is 0, that means we go into white loop. So we need to check if D... We need to do JQ, basically. JQ is basically just an assembly instruction. So you can write assembly instruction. Assembly instructions come from the ALU, by the way. The ALU is the arithmetic logic unit, where you define the arithmetic logic that you want your CPU to be able to perform. And then assembly code is basically just calling those ALU commands that you've defined using logic gates. For people who don't know how assembly works, at least that's how I think assembly works. I feel like there's probably other stuff in there, Anyways, let us load fail ASM. It's already running. It shouldn't be. At 25. Right. 16,384 and 8191, right? So 16,384 and 8191. Okay. Run. Oh, I need to press a key. Sorry. So if I press a key, the screen goes black. If I press a key, the screen goes black. If I don't press a key, it just keeps looping here. And I don't want it to do that. I want the screen to go white. So I need it to go into white loop when I don't press a key. Why is it not going into white loop when I don't press a key? Yeah, that's strange. Because this is end. Right, end doesn't need to be defined. White loop can be defined. White end and end don't really need to be defined. We just need to go back to 0 basically. White loop, however, does need to be defined. So we need to go to add white loop if d here is equal to 0 when we go. So yeah, why is it not happening? Let's check now, actually, now that we've removed the ends. Okay, we'll do select local file. Right. Run. When I press a key, oh wait, I need to set these to oh, sorry. 16. I need to disable keyboard. 16,384 and 8191. I feel like we need to do that through code at some point, because I shouldn't actually. That's not what the program requires. Okay, so white loop. We're in white loop, and then I will press a key, and we go into black loop, and then we just never go back into white loop. I'm so confused. Why do we never go back into white loop? Hold up. It's here. It's stuck at 17. Wait, something is wrong with our white loop. I think that's what's up. Something is wrong. Also, I need to pee. Something is wrong with our white loop. I'm gonna go pee real quick, and then we'll figure out what's wrong with our white loop. Y'all enjoy the music. In the meantime, I also haven't finished my coffee yet. Right, one sec. I forgot to unmute my mic. We back now though. Okay, why are we getting stuck in white loop? So j is equal to 0. Oh, because once we've made it black, R1 gets set to 0. So R1 needs to get set to 8191 again at the end of every loop. So what we need to do is essentially, before we even begin anything, we just need to set so at 1, because that's the value of R1. I guess we can do R1 as well. At R1 we need to set M to 8191. I don't know if we can just set M to 8191 though, just like that. How do I set anything to 8191? Can I just do 8191? I feel like I can't just do that. I don't think I can, because I can only, you know, do 1s and 0s, or up to 255, which 8191 is not 255. It's way bigger. I mean, I can see if that happens. But yeah, anytime we go to 0, it should set to R1 to 819. Let's see if that works though. Let's see if that works. Line 2 expected one of these, but got something else, right? How do we set it to 8191? How do we do that? Is there screen size or something? Is that a thing we can do? Or do we copy? Yeah, because I need to set 16. Hold on. I need to see the variables basically again. I like how my Twitch chat just keeps disconnecting and reconnecting. I don't know how well the Twitch stream is going, to be fair. Like, I don't know if it's like crunchy or unwatchable or whatever, because technically I am on a VPN and I don't know if Twitch works well with VPNs, just in general. So like the Twitch side I haven't been paying attention to for a hot minute, which I'm sorry about. Yeah. Alright, anyways, what am I trying to do? What am I trying to do right now? I'm trying to go see if there's some way that I can have a variable that lets me assign the screen size to an integer. It's not an integer, but you know, to like I wanna keep track of screen size. And I don't know if I can do that. Symbolic programming, there is variables. Like there are variables. I've used variables right now. I use loop and white end and white loop or whatever. But how do I do that now? Because after the loop I need to reset, right? After the loop I need to reset. And I don't know where to do that. R1, can I just call it screen? Hold up. Okay, variables. There we go. The code writer is allowed to create a symbolic variable as needed. We assume that there is an agent who knows how to bind these symbols to sensible RAM addresses. This agent is the assembler. That's fair. If the assembler will bind I to 16 and sum to 17, every instruction I and sum will end up selecting RAM 16 and 17. Invisible to the code writer. That's fair. The result, a powerful low-level variable. What about constants? Yeah. Using only the instructions shown up. Get it? I get it. I actually do get it, to be fair. So if I do 8 at 8191, right, I can copy that value into D. Copy is just like, D is my short-term memory, by the way, which is a very befitting name for something that has short-term memory, because, you know, D's, I'm not gonna complete that joke. Right, and then I can go into basically R1. I can go into R1 and just do M equals D. And then do the same at 16.8. What is it? 16.8 what? 16.384 basically. Yeah, so 16.384. Do the same thing. D equals M. And then go into R0 and just do M equals D. So we're copying the. No, it needs to be A. Right? It's A. It's not. Yeah. And then M equals D and D equals A. We're copying that memory location. We're just remembering it, and then we're copying it back into the places we need it. And we do that every time we go back to 0. So technically that should work. Okay. So what happens when I run it? And then I press a key. Wait, where is it? So if I press a key, it should. Right now it's running through white loop, right? Right now it's running through white loop, but when I press a key, it should. Oh, it's jumping back to 33. Hold on. It's never jumping back to 0. It's always jumping back to 33. Why is that? Because I just make it jump back to 33, right? Loop. Yeah, it just jumps back to loop. It needs to jump back to loop when it's ended, not just always. Yeah, it needs to jump back to loop when it's ended, not always. Hold on, what did I screw up there? Do 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 do. Do 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 do. Do 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 do. At loop, and then it just jumps back here when it's not supposed to. It's supposed to jump back when I is basically equal to 8191 essentially, right? How did I do that before? Hold on, I'm just gonna find the code that I copied initially so that I can remember. Don't add a bookmark. Loop. There we go. Did go to loop. Okay, what's going on? It there we go. It goes back to loop, right? I is increased. D is equals M. It needs to, so when this D, this R1D, when this equals 0, when this equals 0, it needs to go back to 0, and then at 0, it assigns, at 0, it assigns it back to 8191, and then it ends up back here. Right, so it needs to go back to 0 and then get assigned again. Like, I feel like it should work. It's just that we need it to be fast, essentially. And when we press a key, then we release a key. When we press a key, it goes black. When we release the key, it should go white. But it doesn't. It remains black for some reason. Technically it should go white. Okay, hold on. I'm just gonna make it that fast. Right. Why doesn't white loop work? Why isn't white loop working? M needs to be assigned to 0 here, and it is. That's what it is, right? It's assigned to -1 here, and assigned to 0 here. Like, it should set the screen white. Even when I run it, it should set the screen white. Like these, stop. Disable keyboard. Like these can go 0, right? These, stop. Okay, these would all go 0, right? And so when I play it, it would go white, and then when I press a key, it would go black, and then when I play it again, it should go white again. Like when I release a key, it should go white again. What is going on? Like these values aren't changing back is what's happening, essentially. Because I and J, no, I and J should get set back to 0, right? Oh, the white loop starts before. Okay, so when it because so what's happening is I goes to 8191, J goes to 8191. Now when we actually go into the loop, it's already set to that value, so it doesn't change. Yeah. So what we need to do is just put these inside here, essentially, right? Just throw these inside here. Yeah, just throw these inside here, essentially. But then, no, we can't do that. Hold up, no, we can't do that because then every time the loop resets, it'll set it to 0. What we need to do is set I and J up there. That's what we need to do. Yeah, set I and J before our keyboard tracking, basically. Right, so before our keyboard tracking is when we should set I and J to 0. Yeah, before our keyboard tracking is when we should set I and J to 0. So they're like global variables, basically. And then our keyboard tracking happens so that we do white loop and black loop, or white loop and loop, essentially. Yeah, this should work now, I think. So we run it. Yeah, so when I press a key, any key, it goes black. When I press a key, any key, the screen goes black, and then when I release the key, the screen goes white again. Basically, when I don't have a key pressed, white loop is running. When I do have a key pressed, black loop is running. Lovely! Figured it out. It's very inefficient, to be fair, but it works. And I don't care, because it works. Okay, lovely! What am I doing? I should go read if that's all I need to do, because I don't actually know if that's all I need to do. Project 4, right? Project 4? No, that's not the project. Project 4. Fill ASM. This program runs an infinite loop that listens to the keyboard. When a key is pressed, any key, the program blackens the screen entirely by writing black in every pixel. When no key is pressed, the program clears the screen by writing white in every pixel. You may choose to blacken and clear the screen in any spatial order, top down, bottom up, as long as pressing a key continuously for long enough will result in a fully blackened screen, and not pressing any key for long enough will result in a fully cleared screen. Okay, I think we're doing that, right? That is what's happening. So if I press S, it blackens it. If I remove S, it whitens it, right? Press enter, it blackens it eventually. Yeah, okay, cool. Let me just load in the test script. Fill.test, select. Let me run that test script. Select the highest speed and enable. Oh, highest speed, run. The browser died. The browser just died. Yeah, stop. Okay, sorry. I'm gonna have to reload. A duplicate tab. Browser straight up died. Sadly. Okay, test script. Automatic test script, I guess. The script can be used to test the fill program. I'm gonna have to load the fill program again as well. Fill.asm. And then also automatic test select, right? Let me just run it real quick to see that it's working. Enable keyboard. Hold up, run it fast. Run. Okay. Yeah, it's working. Great. The script is used to test the fill program automatically rather than interactively. Specifically, the script sets the keyboard memory map to 0, 1, and then again to 0. This simulates the act of leaving the keyboard untouched, pressing some key, then releasing the same key. After each one of these simulated with the script outputs the values of the same to the registers. This is done in order to test that these registers are set to okay, as mandated on how fill should work. This is how the events should react. So let's just like run it. Right. I feel like the browser is about to die again. It's probably making my stream drop frames. Right, I dropped frames. I've dropped some frames here and there. I don't know why it's like doing that. I have hardware acceleration too. So sets it to 1. The screen starts going black. Right, eventually gets there. I'm also running it on slow mode, to be fair. If I run it on fast mode, I feel like it's gonna crash the browser again. Which I don't know why the browser is crashing, to be fair. It shouldn't crash on this. It really shouldn't, considering I like play Krunker.io and stuff. It really shouldn't crash on just this, but yeah, it works. We know it works. No, we'll stop you. Okay, we'll stop you. Yeah. Fill. Okay, what does fill test do normally? Select the highest speed and enable keyboard, then press any key for long enough. Right. We know it works. And it works as intended. I think that's fine. The testing can't be done, but we know it works. Perfect. I don't know what I'm supposed to do in the next one, but we're gonna mark that in the daily to-dos as done. You've done Phil ASM. Ooh, I need to pee again for some reason. We have done Phil ASM. Lovely. Only took me about 2 hours of stream. To be fair, I did spend a lot of that time just like faffing about and not actually coding. So technically took me less time. Took me less time. I did drop some frames there though in the middle. I dropped 3,000 frames at some point. Probably when the browser froze up is probably when I dropped a bunch of frames. I don't know. Probably happened at some point. I feel like I should open up Twitch chat on my phone just because like it keeps disconnecting on my screen. Twitch chat keeps disconnecting, so I don't actually know if any activities happened in Twitch chat because it straight up doesn't tell me. I also don't have the Twitch app anymore because the Twitch app is garbage, yo. Twitch app is straight up garbage. I don't know what I'm gonna do next, to be fair. I need to do a GDD. I want to combine Twitch and YouTube chat in a thing. I feel like Conway's Game of Predators and Prey is probably what I should get to. Since that's a small thing, and that's basically a project I'm using to teach myself Godot. I'm obviously not gonna do chores on stream. I feel like we can start Conway's Game of Predators and Prey. These are all things I don't have to do on stream. Yeah. So yeah, we're gonna learn Godot. I'm gonna go pee and then I'm gonna come back and I'm gonna change my title and stuff. But yeah, that was fun. We coded assembly. Actually coded assembly. It's really not, you know, it's not as, what do you call it, efficient as it should be. Like 57 lines of assembly, but still, we did it though. I feel like it can be done in one loop. That's the thing. Like, I feel like the only difference between these loops is literally a 0 and a -1. We could easily do it in one loop. I might try to do that off stream though. Just like, yeah. Like if a key is pressed, just go to like checking for the key here. Sorry, not here. Here. Checking for the key here. We could set this value to a 0 or a -1, and then it could just happen in one loop instead of two. I feel like that would work. That would work. But yeah, we can figure that out later. For now, I need to go pee, so I'm a BRB. Did I finish my coffee? I still haven't finished my coffee either. I keep forgetting about it too. It's finished now. Right, okay. Y'all enjoy the music. I'll BRB. I'll change my title then, as well. Oh, I'll run some ads too on Twitch so that, you know, you don't have ads again. Alright, I'm back. Okay, I'm gonna change my title on both Twitch and on YouTube. If it lets me. Is it gonna let me? It's letting me right now. Teaching myself Godot. Teaching myself Godot, yeah. Alright, we gotta go do that on YouTube as well. Teaching myself Godot game dev. I'm gonna put some sparkles. I'm not gonna put some sparkles on YouTube actually. Yeah, actually no, we can. Hold on. I have a sparkly keyboard. I keep forgetting that I have a sparkle keyboard. Where's my emoji keyboard? It used to be right here. I used to be able to just right click and open up emoji keyboard. But I don't know if I can still do that. Hold up, sparkle, I'll just Google sparkle emoji, right? Sparkle emoji. There we go, and we'll just copy paste the emoji. Game dev. I can put it in my Twitch title as well, I guess. Teaching myself Godot, game dev. I can go put it in my Twitch title as well. Hold on. Teaching myself Godot. We'll put the sparkles around Godot. Great. And we have sparkles in our title. Okay, so in order to teach myself Godot, what I am gonna do is I am going to be creating Conway's Game of Life, which is essentially a simulation where you have grid squares, and then something takes up a grid square, and then there's some conditions which allow it to sort of like delete a grid square and then move to another grid square. So it makes like little worm-like things. It makes like little worm-like things that can exist on these grid squares, right? And then move around based on conditions. I'll read out the conditions later. They're on Wikipedia. The only thing that I am gonna basically that I'm gonna customize about this is I'm gonna be creating Conway's game of predators and prey. So I'm gonna have grid squares, and then before starting the game, I can select some squares as predators and some squares and prey as prey. And as the game goes, in empty grids, it is, how do I change color in this? In empty grid squares, it is going to spawn little like green things that are supposed to be like grass. So we have two teams. One team is going to be team prey, and another team is going to be team predator, right? Predator team wants to move to team prey and eat team prey, whereas team prey wants to move towards team grass and eat team grass. And when team prey eats a grass block, it's going to be able to increase in size, maybe have an armor value of something. It's going to increase in size, give it an armor value, which makes it harder for Team Predator to win. And same goes for when Team Predator beats Team Prey, it can increase in size and, you know, get bigger or get faster or something. We can figure out the rules later. But we start with base Conway's Game of Life, and then we make Conway's Game of Predators and Prey, and I want to do it all in Godot because I don't know how to use Godot. I've done 2 Godot tutorials, also BRB. Sorry about that. I got food. A neighbor gave me food. This is crazy. Anyways, yeah, so we are going to try Godot, basically. And somebody wants to sell me cheap viewers. How do I like how that's the first Twitch message, that it's loaded all day. Let me do the thing where I can't right click your name anymore. Sad, because that doesn't work on Linux Mint. I guess I'm gonna have to left click your name and do that. Lovely. It's sad then when that's the first Twitch message that loads up, right? It's kind of sad. Anyways. Right, let's open up Godot. Let's open up Godot and let's figure out Conway's game of Predators and Prey. Can I just open it up from here? I can't just open it up from here. I gotta go open it up from where it is on my computer. 4.3 stable. GMTK rip. I shall create a new project called Conway's game right now. And we're gonna put it in the Godot projects folder, actually. No, can we go here? Right. Does it create its own folder? A project folder will automatically be creator. Okay, cool. Create and edit. We're gonna use Git as version control. I don't know what forward plus is. Supports desktop platforms only. Mobile compatibility. Supports desktop platform, mobile plus web platforms. That's kind of what we want. Least advanced 3D graphics. Currently work in progress. Forward plus. Okay. Currently work in progress. I thought 4.3 just had WebAssembly stuff in it. At least that's what I was told. I was told to upgrade to 4.3 because it can do web stuff directly. Uses OpenGL3 backend, WebGL2, intended for low-end older devices. I guess we'll just go with compatibility, I guess. Okay, and now I don't know what to do. I mean, to be fair, I need to create a 2D node, and I need to add a child node that's gonna be like a sprite node, I assume, right? A sprite 2D node, and then inside sprite 2D node, I can do stuff. I can use a texture. Yeah, I'm just kind of, you know, shitting out my butt right now. So I'm just gonna watch a tutorial or something. Or I could just end the stream and then figure out how to do this but not actually do it, and then just do it later on. I don't know. Let's figure this out. You know what? Let's figure this out. I might need more coffee, to be fair. Ooh. Okay, Godot documentation? No. Brackeys has a Godot. It's an hour long. I've done Godot tutorials before as well. Creating a sprite in Godot is what I'm gonna Google. Creating a sprite in Godot. I just want a sprite on screen that I can move, even though I don't want to move it. How to create sprite sheets. Let's just go to the freaking Godot documentation, shouldn't I? Getting started. Introduction. Alright, introduction to Godot. What is Godot? I don't need to read what is Godot, to be fair. Don't need to read that. I don't really care what it can do. What can it do? Learn to code with GD script. Overview Godot's key concepts. First, look at Godot's interface. Learning new features step by step. Nodes and scenes, creating nodes and scenes. Okay. No. I did this. I did the first 2D game thing, right? I did this. I think this is where we probably begin again. Creating player scene, coding the player, creating enemy, all that jazz. Right. What if I like do grid-based movement in Godot? Grid-based movement in less than 3 minutes in Godot 4.0. That's what I like to see.
This is how you make a grid-based movement system. So first off, we're going to start off with a tile map that just has.
I just realized something.
All over. We're going to have a body, character body 2D from Godot 4. We're going to have a little sprite that represents your character and a collision shape. Let's go into the script, which is going to have nothing in it. So.
Hold up.
This is how you make a grid-based movement system. So first off, we're going to start off with a tile map that just has green all over. We're going to have a body, character body 2D from Godot 4. We're going to have a little sprite that represents your character and a collision shape. Let's go into a script, which is going to have nothing in it. The first thing we're going to do is emulate our grid by using an array. And this array is going to also emulate our position. So we're just going to call it current position equals array 0 and 0. This is going to be our x and y. And to move, we're going to have a function called input. This is going to allow us to check for any sort of input that we put into the game. We're going to say if event dot is action. To event, there we go, is action pressed. We can check for UI right, and then if we go right, what we can do is we can say.
So if I create a tile map grid, if I create a tile map grid, right? Other node, let's just do tile map. Tile map. Create tile map. Tile set, new tile set. Okay, where's the tile set? I don't know what I'm doing, to be fair. Yeah, I feel like I have no idea. I've done tutorials and I don't remember anything because I did like 4 months ago. I feel like I should get started, like, on my own. Yeah, I should go watch the Brackeys thing on my. I mean, I could watch it here too. To be fair, I could watch them together. We could watch them together. Technically, the title is teaching myself Godot. It's not making a game in Godot, so I don't actually need to make the game in Godot. I can just watch the Brackeys thing and like try to do my own thing along with it. I don't know what I'm doing. There's so many nodes. So many nodes. Brr, I don't know which node to select. Okay, fine. We'll just do Brackeys. Brackeys, not brackets. Brackeys. Godot. Godot. Honestly, when Brackeys came back, and in his video he said game changer, and he took a pause, I thought he was gonna say AI. I'm glad he said open source and said he's gonna do Godot stuff, because honestly I really thought he was gonna like do AI stuff, and then we would have to not talk about Brackeys ever again, and it would be really sad. But thankfully he chose light.
Here, add a new sprite frames, and now with
Okay.
Godot, whichever you prefer. If you want to use it
Let me just pause the music.
to make a game, you've come to the right place. I've been making video games for more than 14 years now, and recently I've fallen in love with Godot. Godot is a great choice for many developers, and pretty beginner friendly. Also, it's open source and completely free to use. Now, you probably have a bunch of ideas of games that would be cool to make, but no matter if you're dreaming of making an FPS, a 2D platformer, or anything in between using Godot, the first step is of course to install it. Now, this process might be a bit tedious, but bear with me now.
I have it already.
I can even click it and on my desktop. About Godot 4, make sure to check out Cycle Learning, range of code below to get an extra 20% off the first show. In the spirit of learning the basics of the engine and giving you an overview of how you can start using it to make things, I've put together the most basic game I could imagine. Think of it like food without salt. It doesn't have much flavor, but it does have a player, enemies, moving platforms, collectible coins, and most importantly, it should get you familiar with the engine in no time. Also,
I just want to be familiar with the engine. I know how to do stuff.
Concepts to 3D. So don't worry, if your dream game is in 3D, most of what you learn here is going to directly apply. As for programming, Godot uses its own scripting language called GDScript. It's pretty fast and easy to use, but still quite powerful.
Why am I so burpy? It's probably because I had
but the main focus
coffee.
is to get familiar with Godot as a whole and to quickly get a game up and running. Because of this, I don't expect you to fully understand all the code you see. Feel free to write after me or just lean back and observe. Our next video will be about learning to program in GDScript. Alright, I promised you food without salt, so let's get cooking. Now, to make our delicious game, we need ingredients. We need things like sprites, models, textures, and sounds. These are called assets, and a game engine like Godot is not so much made for creating these from scratch, but more for putting everything together. It's really the starting part of making a game. Now, since I can't expect you to go shopping for assets at your local supermarket, I've used a bit of TV magic to prepare some beforehand. You can download them for free using the link below. I've bundled together sprites from the amazing Analog Studios and modified them a bit, along with a pixel font, some custom sounds, and a cute little music track. It's also perfectly fine to use other assets you find on the internet. There are many great resources for free assets, just make sure you check the license and give proper credit to the author. CC0 means that the asset is completely free to use and there's no requirement to credit. That being said, making your own assets is one of the places where you can really get
I
creative.
mean, I'm just gonna use white and black squares to start. Literally trying to make Conway's game.
Into Godot. Importing assets in Godot is extremely simple. The file system window is where we have all the files we use in our game. By default, the only thing in here is the Godot icon. So let's create a folder where we can put our assets. Let's right-click, new folder, and name it assets. Let's also make one for scripts and scenes that we can use later.
I'll make a scripts folder, I guess. New folder. I call it scripts. Okay, it goes into res, which is, I'm guessing, my main folder. I don't know. Yeah. Cool.
Drag and drop our assets into the asset folder. So I'll select the assets folder, open up my assets.
I guess
here,
we can make a scenes folder too, right? Create new folder, scenes. I bet there's a shortcut to do this as well, instead of having to right click each time.
Select all the subfolders and click and drag them into Godot. And voila, we can now see and use all of our assets in Godot. So now we're ready to make our game. So let's talk about how we do that. To make anything in Godot, we use nodes. If we want to make a player character, we do so by putting together a bunch of nodes. If we want to make an enemy, we do so by putting together nodes. If we want to make a main menu, you guessed it, we use nodes. So nodes are the fundamental building blocks of your game. And nodes come in many types. Some display an image, others play a sound, or add physics. And we can even extend existing nodes to build more powerful ones. So in its essence, making a game in Godot is combining and extending nodes to get the result we're looking for. It's a super creative and fun process. But building everything in one big world with nodes for the player, enemies, UI, and a bunch of levels all in one place would quickly become completely unmanageable and confusing. Instead, we use scenes. Scenes allow us to bundle together nodes into reusable packages. A scene can be a character, a weapon, a menu. They can be as small as a
I'm assuming what we need is basically like an empty grid, right? That would be a sprite. We need a filled grid initially to start off with and that would be a sprite. And then we'd probably need a different color filled grid to represent a different thing sprite, right? Should have chosen like a contrasting color like that. Yeah, we'd need those three sprites essentially, but first we would need like an empty grid thing. I can just use like the SVG icon that comes with Godot and just like to represent, you know, grid, just to make a grid essentially. And then when we click it, initially we can just make it disappear, but then we can replace it with like sprites. Yee.
Or an entire level. Scenes make it really easy to focus on building one part of our game at a time, and then slowly combining them to make our game larger and larger. This is because we can put scenes inside of other scenes, which is called nesting, and allows us to take, say, a player scene, a platform scene, and a collectible coin scene, and put them all inside of another scene, say a level 1 scene. And even cooler, since scenes are reusable, we can make a scene only once and then use it all over our game. We can make many levels that all use the same collectible coin scene. And if we want to change something about our coin, we simply edit the scene, and it automatically updates everywhere else. As you can see, all the nodes and scenes in our game start to resemble a tree-like structure, and that's exactly what we call it, the scene tree. And fittingly, we call the node at the very beginning of the tree the root. So now that we know a bit about how Godot works, let's start by making the most essential part of our game, the player character. Player 1.0. So let's create a scene where we'll put everything together. This is going to be a 2D game, so I'll select 2D scene, and let's rename this from node 2D to game. And even though it's empty, let's go ahead and save it. So hit Control S, go under scene.
Okay. Create a 2D scene and just call it game. Which is fair. I mean, in-game scene, right?
And let's save it here. And now we can actually play our game. It's not going to be very exciting, but let's try it out. So let's hit play up here, or simply press F5. It's going to tell us that we haven't selected a main scene. We need to tell Godot which scene to run. I'm just going to press select current, and you can see that our game scene becomes blue to let us know that this is now our main scene. And
if I do that, select current, and then I'm just going to save it, right? Cool, lovely. Save it in scene. That's the game.
you can see, not much is happening here. So let's stop playing by hitting the stop icon here or pressing F8, and let's put in a player to make it more exciting. So first off, let's create a new scene by hitting the plus sign up here, and this will be our player scene. And the root node for our player is going to be what is called a character body 2D. So let's add a new node by pressing the plus here or hitting Control A, and let's search for character body 2D. As you can
Do I want it to be a character body 2D though? I don't know. I don't think I want it to be a character body 2D, right? I feel like I should want it to be a sprite 2D. It's not a character body. It's not a character body.
This is a 2D physics body that is specialized for characters moved by script. So it's perfect for a player character that we want to be able to collide with the environment. So let's hit create, and now we can see our node here, but we can't actually see our player in the scene. So let's add some graphics. Let's add another node. I'm going to hit Control A, and let's search for sprite. And as you can see, we can choose a single sprite, or in our case, we want to create an animated character.
Would a grid be character body 2D? It's not. What about UI? Are there UI scenes? Hold on. I click add. What's UI? Do we have UI? Like, do I need something to be a UI thing for it to be clickable? Also, what's GPU particles? A box-shaped 3D particle collision shape affecting GPU particles 3D fair. An interface to a game world that doesn't create a window or draw to screen directly. General purpose sprite node. What about character? Okay. Character body 2D. A 2D physics body specialized for characters moved by script. See, I don't think I need that. Because I don't have physics. Like it's basically rigid body, right? I wouldn't need rigid body 2D if I was making this in Unity. So I don't think I need that here right now. I do need a collider. I feel like if I just have a sprite 2D, right? If I just have sprite 2D, and I call it, rename it to, first of all, I should create a scene, by the way. I don't know how he made a scene. Scene? What is this? A 2D game object inherited by all blah, 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 blah. How do you make a new scene?
Sprite. First off, let's create a new scene by hitting the plus sign up here, and this will be our players.
Okay, there we go. So, so this scene, this 2D scene, is gonna be called grid, right? Grid, which is an object essentially, and then we can just save it as grid, and then inside grid we can do a sprite 2D. Yeah, do a sprite 2D.
And the root node character, click that. So let's choose sprite to change properties on that node. If we sprite, and as you can see, we can choose a. Now with this node space, we want to create an animated character. So let's choose the animated sprite 2D. Sprites are just what we call images in our 2D world. Now with this node selected, we can use the inspector here on the right to change properties on that node. If we select a different node, say our character body 2D, we can now see the properties on that node instead. So our inspector allows us to change things about a node. In our animated sprite 2D, we want to add some animations. And we want to give it some sprite frames, the individual frames that will make up our animation. So let's click here and add a new sprite frames. And now with this selected, we can see that it will open up.
So, texture, new image texture, canvas texture, texture 2D. Sad. Load this into there, right? Okay. I don't know what that counts as, but just load it there. Feel like we'd be able to select assets like that. I don't know what these are, but yeah. Cool. It's there now.
This sprite frames window at the bottom. And in this window, we're going to press this tiny icon here that lets us add frames from a sprite sheet. So let's click that, go into our assets, under our sprites, let's find our knight.png. And as you can see, I've gone ahead and packed all the different sprite frames of the knight's animation into a single image. This is called a sprite sheet. It's a very efficient way of working with lots of sprites, such as when doing animation. Otherwise, we would have to create an image for each single frame, which would quickly become an unmanageable amount of files. Now to start adding these frames in, we first need to configure the grid here. Currently it's set to 4x4. Let's go ahead and increase this. I've created an 8x8 grid here. And as you can see, each frame now has its own grid cell. And let's just start by adding the idle animation. To do this, we simply click the frames in the order that we would like. So I'm going to go from the left-hand side here and click. As you can see, it says this to 0, the first frame. Then I'm going to click the next one and the next one and the next one. And now it goes from 0 to 3 and we'll play from left to right. We can always click again to remove. And this is how you can quickly build an animation from different parts of your sprite sheet. So I'll select these 4 frames and hit add frames. Now let's hit F to center our character on the screen. And I'm going to use the scroll wheel to zoom in. We can also click and drag with the middle mouse button to pan. Now our character looks weirdly blurry. That's because we're working with pixel art.
I think what I should do is actually create the sprites. Yeah. Which would be like a empty grid and filled grid and colored filled grid, 2 colors. So that technically it would be an animated sprite 2D. It would be an animated sprite 2D, but we won't actually have it be animated. We would select, you know, unselected is frame 0, selected is frame 1, and then, you know, frame 2, 3, whatever. We should do that. But also, I feel like I should end stream because I've been going for like 3 hours, 2.5, but still, and just do this tomorrow or day after. I don't think I'm going to stream tomorrow, but I could do it day after. I feel like I should do that. I should do it a little bit off screen. I don't want to do it all off stream. I could just take like a 15-minute break and see. It's almost 5 p.m. too. I feel like I should hop off at 5 p.m. as well. I don't know what to do. let's take a 5 to 10 minute break, I would say, and then we can figure it out. Yeah, cool. I'm gonna take a 5 to 10 minute break, and then I'll be a bee, and then we can work. Yeah, break time. Ooh, okay, we back. I just kind of went outside and got some sun time. Also had some fruit. What? Let's get to it. Let's get to it. Okay, so a sprite. I'm pretty sure I have a sprite. Don't I? A sprite? Yeah, there it is. I just have to open it from a terminal. Right, okay, hold on. If I do new, I should aim for 16 by 16, yeah. Yeah, if I do new, and I just want to make a square. To be a grid item, right? Simple square, save as or export. Let me find that folder. Where'd that go? Rip. Did I crash a sprite? I think I crashed a sprite. Hold on. Yeah, I crashed a sprite. I didn't crash it, but you know, I tried to do a thing. A sprite. All right, let's try this again. Just make a white square. All right, just make a white square. Export as not here. I want it to be in Windows. That's the thing. Not Unity game, but Godot projects, Conway's game, assets, and we're just gonna call it grid. Grid. Yee. I guess we can call it grid empty. Grid dash underscore empty. I'll just do dash. Grid empty. Right, and then with green, or not green, should be red versus blue, and then green is the grass, right? So with blue, we'll just do grid full. Grid blue, grid blue, grid, that's red, right? I am colorblind. Grid red, and then we'll do a grid green. Grid green. Right. So we'll do grid green. Okay, perfect. And then now here, they should just be here. Right, so we can throw that in there. And then now we have a 16 by 16 grid, except Brackeys is gonna tell me why it's freaking blurry.
Requires really hard edges. By default, Godot is going to try to do some texture smoothing to make textures look better, but applied to pixel art, that is definitely not the case. So let's simply disable this. So let's go to project settings, let's go under rendering to textures, and here on the default texture filter, let's change this from linear to nearest, which will
Project settings, rendering textures. Project settings, rendering textures. Nearest, I guess. Yeah, nearest. Okay, let's see.
immediately make our pixel art look crisp. Then we can select our animated sprite. Let's try playing the animation. That looks great. I'm going to increase the FPS here to 10 to make it go a bit faster. I'm also going to rename the animation here to idle. I'm going to enable autoplay to make sure it plays right when we start the game. And finally, I'm going to take this right here and move it up to make it kind of stand on this line. And that's it for our graphics for now. We'll add more animations later. But as you can see, we're currently getting this warning here in the scene view. And if I hover over it, it's going to say that this node has no shape, so it can't collide or interact with other objects.
Shape. So if we do shape, that's a collider. Shapecast 2D or collision shape 2D? A node that provides a shape 2D to a collision object 2D parent. Brackeys help.
This is because a character body 2D is a physics node, and whenever we're working with physics, we need to define a shape that the physics engine can work with. So let's add a new node. I'm going to press the plus sign here. I'm going to search for collision shape 2D, hit create, and here in the inspector, we can now define a new shape. I'm going to add a circle shape. I'm going to make this a bit smaller and drag it up. Somewhere around there looks fine.
Alright. Yeah, I guess we give it a shape, right? Collision shape 2D, shape square, rectangle, and then just make it the size of the thing. Just make it the size of the thing. Right. So that's how we do collisions. Collision shape 2D only serves to provide a collision shape to a collision object 2D derived node. Please use it as a child of area 2D, static body 2D, rigid body 2D, character body 2D to give them a shape. Okay, so or I guess, yeah, it should be okay. So wait. Area 2D. Okay, what's Area 2D? Area 2D is a region of 2D space that detects other entering. Yeah, that's basically what we need. So Area 2D and then sprite and this can be a grid square. A grid square is just an Area 2D thing. Okay. So the grid would be like the whole grid, and then an Area 2D is just like a grid square in it. So a grid would consist of multiple grid squares.
You're probably thinking, well, this is pretty far from our actual graphics, but that's totally fine. Colliders rarely need to be very precise, and it's a good rule of thumb to make them a bit smaller than the graphics if you need to. Having colliders that are too large is simply going to be frustrating when playing. So let's now rename the top node here to player, and let's save the scene, Control S, as player, hit save, and now we can go into our game scene and simply drag our player in here. So I'm going to go to the top here and drag in the player. We also need to create a camera so that we can control what is currently being shown. So let's add a new node, hit Control A, search for camera 2D, hit create, and now if we press F, we can see that we have this huge camera viewport. This is definitely currently too large, so let's zoom in on our camera. I'm going to set the zoom here to 4x4 and simply click and drag our camera to be on top of the player. And now we can try playing our game. And there you go. We now have a player that is playing an idle animation and nothing else is happening. That's because we need to add a script that allows us to move around. So let's close our game, go into our player scene, and with our player node selected, let's press this add script button. Here we can choose a template. Of course, we're going to do some programming in this video, but writing player movement can quickly become a bit overwhelming. So for now, we'll use the basic movement template provided by Godot. Then later, we'll go in and modify it to play different animations and rebind input to the keys we'd like to use.
I don't want to
As for the
do
add
any
here,
of
we'll make
that.
sure that we put this inside of our scripts folder, and let's just name it player. Let's hit create.
I don't know why
Let's
I'm
see
just
that
like
it's a script that will move
sniffing
around our character.
out
I know
here.
that this might look really confusing at first, but don't worry, we'll have a look at what all this means later. For now, let's just try playing. And our player immediately falls off the screen. That's because we need to give him a collider to stand on. Right now, our player has a collider, but it doesn't have anything to collide with. So in our game, I'm going to go back to the 2D view at the top here. This is where we can change from script view to 2D. Let's add a new node. So let's hit the plus sign. Let's add a
I just want to
body
detect a
2D.
click
This is
on
another type
top of
physics
the
body, so
thing
one we use for
and
physics.
also like initialize a grid essentially, and then just detect clicks on it. That's what I need to do, right? That's all I need to do. How do I do that? So yeah, we have our grid. It only has one grid square. We should just call it grid square. We should call it grid square, and then just have this be area 2D on its own. And then if we go into scene and game scene, can we just drag grid in here, right? It's so tiny. So unbelievably tiny that it doesn't even render. Why does it not render though? Why doesn't it render? It should render. Visibility is on. Yeah, why it no render? It should, technically. It's a square. Right, at 100%. It's so tiny, but you can still see it. So why can't you see it here? And how do I make it so that have I just not saved it? Is that the thing? I probably just haven't saved it. Yeah, there you go. Okay. Right. Also we should rename you to grid square. Yeah, we should rename you to grid square. Grid square. Right. So go back to game and copy grid square in instead of grid, and then just put it there. Okay, so we have a grid square. We need like something like a game manager that can initialize a bunch of grid squares, right? Programmatically. How do I do that? Is game manager a thing? No, game manager is not a thing. I guess it would just be an empty node with the, yeah. Okay, initialize. I should just keep watching the Brackeys
But we need
video.
to move. That's why it's called static. So it's perfect for creating some ground. Let's hit create. And again, this is going to give us this warning here that it needs a shape. So let's add a collision shape. So I'm going to hit Control A, search for collision shape. And for the shape here, we're going to create a new world boundary shape. The world boundary is a type of collider that is perfect for stuff like, well, world boundaries, because it's going to extend infinitely on the horizontal axis here. So as you can see, it's currently pointing up. We could also point it to the side here, and now it's going to extend
I guess
infinitely on the vertical.
Godot, the thing with Godot is I really need to know what nodes are. I think that's what the thing is. I really need to know what nodes are. I'm trying to make it so I'm always center frame, and I'm not always center frame. I don't have NVIDIA broadcast anymore, otherwise I could have just made it so that it centers my head on frame every time. But now I'm having to like move the camera on my own. Could just get rid of the mask as well. I feel like the mask is nice though. Could just make the mask bigger. Yeah. So what I'm thinking is, yeah, I need to know basically every node to know Godot.
I'm going to hit Control Z to undo that. Instead, I'm going to select the entire static body here. I'm going to change to the Move tool by pressing this icon here, or simply W on the keyboard, and I'm going to move it down under our character. Then I'm going to go back to our Select tool, which is here, or simply press Q. And while our collider doesn't have any graphics, it's going to be invisible. We can now play, and there we go. Our player now gently lands on the collider, and we can move around using the arrow keys and jump with the spacebar. Now, our player is currently a bit too fast, and I think his jump is a bit too high, so let's modify our script to change that. Let's close our game, go into our script, and at the top here, there are two constants that we can modify, our speed as well as our jump velocity. So I'm going to set the speed to something less like 130, and the jump velocity to say -300. And now when we play, it looks and feels a lot better. So our player is moving around, but currently there's not much to look at. So let's build a world to explore. World building 1.0. So to build our world, let's begin by removing our collider here. We're going to build an actual ground for him to stand on, and let's instead add a tile map node. So let's press New Node and search for tile map. Now, the most common way to create levels in 2D is by using tiles. In other words, we build our game world by drawing different tiles onto a grid. This is a great way to work because we can create a lot of varied levels using just a few tiles. The tile assets we use to paint are normally packed together into one big image, just like our player was. This is called the tile set. So the tile set is a collection of tiles that we can use to paint from, and the tile map that we just created is the node we use to paint these tiles into our world. So to start painting on our tile map, we need to add a tile set. So in our inspector under tile set, we'll create a new tile set, and if we get to configure some things about it. The main thing we want to make sure is set correctly is the tile size. The tile set in our asset does indeed have 16 by 16 pixel tiles, so we'll just leave that as is. Now at the bottom here, you can see that we have two tabs. We have the tile set and tile map. So before we can start painting with our tile map, let's go into our tile set and configure this property. The main thing we want to do is drag in our tile set asset. So let's go into our assets folder under sprites and drag in the world tileset.png. It's going to ask us if we would like to automatically create tiles in the atlas. We do, so let's press yes. And now let's make some more room here, and we can zoom in to view it. And as you can see, it's actually gone ahead and automatically detected the grid cells that have tiles. If for some reason it's made an error, we can always use our eraser here to remove tiles. In this case here, it thinks that the top of the palm tree is a bunch of different tiles. I'm going to use the eraser to get rid of these, and instead go out of the erase mode, and then hold down shift while clicking and dragging to turn this into one big tile. It's also split up the trees into 3 different tiles, but in this case, it's actually something that we want because it allows us to create trees of varying heights. I'll show you this once we start painting. Other than that, I think it looks good. So with this tile set up, we can now go to our tile map and start painting. Make sure that the scene has the select tool and that the tile map has the paint tool enabled. And now let's simply select a tile and start painting it in. If you make a mistake, you can always right-click to remove. So I'm just going to fast forward through me drawing out the level here. As you can see, I begin by blocking out the most essential game parts, leaving in room for gameplay objects like moving platforms and enemies. And then only once I'm finished with that, I start decorating. And if the trick here is that you can select multiple tiles at once to paint in more than one, and you can always go into select mode in order to select large chunks and move them. Now once I'm ready to start decorating, let me just show you the cool trick with the trees here. So let's say we want to add a tree here at the top. Well, then we can actually just paint the bottom and choose how tall we want the tree to be and then paint the top. So that's one of the advantages of working with tiles, is that we can also make individual elements really, really flexible. So once you're happy with the level, let's just go ahead and press play, and our player is going to fall right off. That's because we need to add a physics layer to our tiles. To do this, we go to our tile map, go under our tile set, physics layers, and add a new layer. Then with this layer, we can go under our tile set, and then we need to choose what tiles belong to the physics layer, because we don't want to collide with everything in our tile map. The trees and bushes, we just want to pass right through. So let's go to paint here, and the property that we want to paint is the physics layer 0 we just created. And now we can actually go ahead and paint onto our tiles these physics settings. So I'm simply going to paint this onto all the different solid tiles. And if you make a mistake and want to remove a tile, we go here, select clear, and now we can paint with no physics, or we can go back to the default tile shape, which is the entire tile.
This is useful to know
So
for when I actually make something with a tile map. Right now we don't need that.
Such as our bridge here.
So if I know how to initialize. Initialize Godot. Godot. It does have a dot initialize, but probably not in the way I want it to.
It doesn't look right. Instead, we need to go in and only paint a partial collider. So over here on the left, we can actually modify these colliders to exactly suit our needs. We can even add and remove points by clicking and right-clicking. But in this case, will be just fine, and that's a good shape for our collider. Then we can paint these onto the 3 different tiles, and then for the next, and here you actually want to drag it here. And for the root node here, we'll search for sprite and select the form. That looks good. Now when we can see our sprite perfectly cropped out. Again, we have the warning here, so let's go ahead and add the collision shape 2D.
Dying probably helps.
Dying 1.0. So we happily move along in our world until suddenly we miss a jump and fall into the abyss. And then nothing happens. Let's change that. The first thing we want to do is limit our camera so that it doesn't follow our player when we fall down. Luckily, this is really easy to do. We simply select our camera under the player, go under limit, and here we can set a position limit for the left, top, right, and bottom part of our camera. In our case, we need to set a limit for the bottom position. To do this, we can use the ruler tool here at the top, or simply press R, and then the baseline here to where we would like the limit of our camera to be. I think a good value would be somewhere around, say, 120. So I'll simply go back to select mode and put in 120 pixels on the bottom. I'm also going to enable smoothing, and now when we play, we can see that our camera will follow the player, but whenever we fall off, it's simply going to stay put. Next, we need to detect that our player has entered the dangerous area and restart the game. In other words, we need to create a kill zone. I'll show you a really cool way to do this that allows us to reuse the same kill zone for more than just falling off the map, such as for spike traps, enemies, all kinds of elements of danger. And when we want to create a reusable element, we start by making a scene. Then to detect if we enter an area, we again use the area 2D node, and let's make sure to set the collision mask here to 2. We only want to check for the player, which is on layer 2, and we won't add a collision shape here. That's because we want to be able to reuse this for all kinds of elements that might have different shapes. Instead, instead, let's simply go ahead and rename this now to kill zone and save it as a new scene. Then in our game scene, we can add it by dragging it in or simply pressing the link button here and selecting the kill zone. And then in here, we'll add the collision shape. So I'm gonna hit Control A, collision shape. And for the shape, we'll use the same world boundary shape that we used earlier for the ground. Now let's make sure to select the kill zone node itself, go into move, and use the move tool to position it down here at the bottom. I'm gonna place it pretty far down so we're sure we don't hit this by accident. Or I mean, we're gonna be hitting it by accident, so let's make sure we don't hit it on purpose. Or I mean, I don't know. Anyways, I'm gonna place it down here a good bit away from our level. And now we can add a script to make something happen when we enter the area. So in our kill zone, let's select it, add a new script. For the template here, I'm just gonna select empty, and the path, let's put it under the scripts folder. And now we have this empty script to play with. I'm gonna connect a signal, so go node, make sure we have the kill zone node selected. And again, we'll use the body entered signal. Let's double click it, hit connect, and it's going to create a new function on body entered, in which case we can go ahead and print that you died. And now if we play and jump down, it's going to print that we died. Now instead of immediately restarting the game, let's add a small delay.
Okay. I mean, he kind of did what I want him to do. What? Whew. I'm so sleepy. But, not really. What I need to do is I need to create a game manager node, I think. I'm not sure. Game manager Godot. Like he does he even do score? World building, enemy, dying, player, text, score. There we go. We need to figure out how he does score. I feel like score is what's gonna help us. Right? Because he's gonna have like a script, like a game manager that you would usually have. That's good. Probably keeping
There are multiple ways of working
track
with
of
text in Godot
score.
as part of a larger UI or as an integrated part of the game world. For this game, I decided to try making the text part of our world. In Godot, a text node is called a label. So let's add one. Let's hit Control A and search for a label. Let's focus on it. And as you can see, this creates kind of a bounding box for our text. So I'm going to put it over here and scale it up a bit. And let's add some text in the field here. I'm going to put in a gameplay hint. And as you can see, the text looks really blurry. That's because since we're using pixel art, we're actually zoomed in really, really far, which makes the otherwise smooth text appear blurry. So we can fix this by, and here we can drag to use to draw on top. So let's use one of these text elements to display our current score. Score and points. To create a score or a coin counter for our game, we need two things: a script that keeps track of our current score and a label to display it. It's common practice to place game-wide variables such as a score inside some kind of game manager. So let's make one. We'll hit Control A to add a new node. Let's rename it Game Manager, and I'll place it.
Knew it. I knew it. Okay, so Control A, add a new node, call it Game Manager. Lovely. And then can I just like go into script here? No, this doesn't have a script.
Right at the top here. The reason why we are using a regular node and not a node 2D is because we don't need our game manager to have a transform, in other words, a position, rotation, and scale. Now let's add a script to our game manager. We'll use the empty template, and for the path here, let's put it inside of our scripts folder. Let's also rename it with non-capital letters. Great.
Okay, that's how you add a script to it. Right. Cool. So, on ready. Right, now we just need to know how to script in GDScript, which is easier. So how do I get a reference to grid square? Can I just like do that? Not really, no. I'm trying to code like I would code in Unity in Godot right now. That's what's happening. That is all that's going on. Yeah.
Let's create a variable for our current score. So we'll write var for variable, name it score, and default it to 0. Now, so far in our code, we've only used the built-in functions of Godot, and some that we made with signals. In this case here, we want to create our own
reference to node object in GDScript. That's probably what I need to know. How to reference node in Godot. I'm using GDScript. How about we just go to Bracky's GDScript thing? I'm sure he tells me.
Called when the node enters the scene tree for the first. GDScript, a high-level, object-oriented, imperative, and gradually typed programming language with syntax a lot like Python built specifically for Godot. I know that sounds like a lot, but today we're going to learn it. While it's of course impossible to cover everything an entire programming language has to offer in just one video, we'll certainly try. In fact, we'll cover everything from variables and conditionals to getting input, inheritance, dictionaries, signals, and the list goes on. And who knows, perhaps we'll even figure out what GD stands for. Gandalf script? Green Day script? Gadolinium? We might never know. We'll start with the things that are considered to be most important for beginners, and then move on to
Godot
more abstract programming
development
concepts as we
script,
progress. It's not as
probably.
much a follow along as it is an overview.
Godot
So if you're a beginner,
documentation
lean back.
script.
I know that you don't have to understand everything the first
Something
time.
like that.
Also, it's totally okay to stop the video and try some
I'm
of these
being
things out.
too
You can always come back to
normal.
it at a later time. We've made sure to split everything into clearly named sections, so hopefully you'll be able to use this as a reference manual going forward. And if you're a seasoned programmer transitioning to GDScript, this video should provide you with a nice overview of the tools at your disposal and how to approach doing different things. Keep in mind that this is a video on GDScript, not an introduction to Godot. So if you've never opened up Godot before, I suggest you begin with our video on making your very first game in Godot. Alright, without further ado, let's learn GDScript. But first, this video is sponsored by Codecrafters. If you've been writing software for a while and are looking to take your skills to a whole new level, working always in Codecrafters. Use the link below to get 1 week free and 40% off on all membership plans. Hello world. So here we are in an empty Godot project. It's really spacious in here. As it is custom, let's begin by making a script and adding some code to print a message. To do that, we need a test scene, so let's go and hit the plus. I'll add in a node, rename it to main, and let's save this as a scene. So I'll hit Ctrl S, hit save. Let's add a script by pressing the scroll. We'll use the default template, and the name of the script should be main as well with a non-capital M. This creates a script with 2 functions. We'll start by focusing on the top one named ready. Think of this as the start of our game. As it says here, this function is called when the node enters the scene tree for the first time, which happens right when we play our game. So we can put code in here that we want to happen immediately. I'll get rid of the other function for now. You can zoom in by holding down Control while scrolling. Now right now the only thing in our ready function is the pass keyword. Pass basically means do nothing, and it will appear in functions we haven't filled out yet. So let's replace it with some code that prints our message. We'll write print, and inside the parentheses we'll put our message in quotation marks, hello world. We can then run the game by pressing this button here or hitting F5. It's going to ask us which scene we're going to run. We'll hit select current. And while our game isn't very exciting yet, we can now see that the console prints our message. The output window here, or the console, is where it will display prints, and is also where we check for errors. Now to stop our game from running, we press the stop button here or press F8. Syntax. Now this might have worked for you and it might not. That's because there are a few things to be aware of when writing. The first is that statements like print here terminate with a new line. There's no need to add a semicolon at the end like in many C-based languages. And GDScript, similar to a language like Python, uses indentation to determine the structure of your code. This means that you use tabs to tell GDScript where your code belongs. In our example here, I'm using a tab to tell Godot that our print line belongs to the ready function. If I delete this tab, I get an error. Also, GDScript is case sensitive, so if I write print with a capital P, I will also get an error. So just a couple of things to look out for there. Now printing to the console is cool. Or I mean, maybe not as cool as backflips, but well, I can't teach you to do those. But I can teach you how to display text in the game window.
Come on,
instead. To do
Brackies,
that,
you
we
can
need to
teach
modify
us
a
to
node
do
group.
backflips.
Modifying nodes 1.0. First, we need a node to modify. Let's use a label. So I'll add a new node, choose label. I'll zoom in, center it on the screen. Make some more room. Let's add a default text. This is a label. I'll center it and override the font size. Now, to edit the text of this label through script, we need 2 things. We need a reference to the label, and we need to access the property in the label that we want to change. In this case, the text.
Show me how to
If
do
we hover over text, we
referencing.
can see the name of the property through script, which is text with a non-capital T. So in our main script, we'll first get a reference, and we can actually do this by simply taking the label and dragging it into our ready function.
I did that. Hold up. If I do this, no, because that's a reference to the scene. Can I just do like grid square? Grid square? No, we can't die. I wanna do that. Is it because it's like it's a scene and not a node? Like, what if I just do this? Grid square? Does that work? Can I just initialize it there? It's like, it's called grid square, right? It's called grid square. Parse error. Okay. Why though? Why can he do it, but I can't do it?
Now we can access the property by going dot, and we'll type in text and set it equal to hello world.
Why though? Hold on. Let's go back here. It's no 2D, right? It's no 2D, but it's a grid square. I mean, it should act as it, like, that's, What if I do the grid square? What if I do this? Does that work? Parse error, unexpected, in class body. I mean, okay, so hold on. Grid square dot what about now? Clear. So no errors currently, no errors. So if I do initialize grid square, right? Initialize grid square. Is that something I can do? I don't think that's something I can do. How about no 2D dot? It's not an OOP. It's just not an OOP. So what can I do though? So if I do grid square dot initialize, I can't. Grid square dot, Can process, create tween, duplicate. Find child, get node, get parent, path, get tree. Position? No. Sad.
And now when we play, our label changes to hello world. And we can use this exact method to change other things as well, such as the color of the text. In fact, there's a property called modulate, which allows us to tint sprites and UI elements. In the inspector, you can find it.
Transform. Grid square dot transform. It's called transform. Transform? No. Grid square dot get node. Get node. Transform. Transform 2D. A. And then I can't do shit. Still. Position. No. Position. Nope. I don't know, man. Dot X. +1. Does that do anything? No, it doesn't do shit. Can't access property. No. Grid square dot duplicate. 15. What does that do? Cannot call duplicate on a null value. Okay, so nothing. How about variable square? Variable square equals grid square. Grid square equals grid square. Parameter delta game manager. Wait. Pass. Not pass, but pass. Let's stop you. Okay, hold on. Debugger. Where's the like output? Play. The default value is using, which won't return nodes in the scene before ready is called. Okay, so that's not how this works. Rip. I don't know how to reference classes.
All the way down here under visibility. Let's change it to green. So again, we'll click and drag to create a reference to the label, right dot modulate, and set it equal to color dot. Here we have a bunch of different colors. We'll choose green. And voila, our label is now green. So this is how we can make changes to nodes when our game is running. But right now, not much is happening during our game. So let's see how we can use green. Green. So again, we'll click and drag to create a reference to the label, right dot modulate, and set it equal to color dot. Here we have a bunch of different colors. We'll choose green. And voila, our label is now green. So this is how we can make changes to nodes when our game is running. But right now, not much is happening during our game. So let's see how we can use input to make our game respond to our actions. Input. Let's say we want to turn this label red when we press the spacebar. To do this, we first need to set up an input action. We'll go project settings, input map. Here we can add actions. Actions allow us to bind keys to something that we want to happen. Common actions would be shoot, jump, or so on. In our case, we wanted to change the color. I'll just go ahead and call it my action, so we can use it later for other things. Now let's hit add, and here's our action. Let's bind a key to it by pressing plus. It's now listening for input. I'm going to press the spacebar and hit OK. And now our spacebar is bound to my action. Then in our script, we need to create an input function. We'll write func for function underscore input. Let's hit enter to autocomplete. Now just like ready, this is one of the built-in functions of Godot, but instead of being called at the start of the game, it runs every time the game receives any input, such as when we press a button. Event is what we call the information about what triggered the function. Was it a movement of the mouse or the press of a key? We need to check if the event that triggered the input was our action being pressed. So we'll write if event.isAction pressed. And as you can see, our action shows up here, my action. Then we'll put in a colon, and if we pressed my action, well then we'll change the color. So we'll drag in the label, right.modulate, and set it equal to color.red. And we can just as easily check if the action was released. We'll go if event.isAction released this time, my action. Well then we'll take the exact same line and change it back to green. So now when we play and I press the spacebar, it turns red, and when I release it, it turns back to green. That's right, we made a party. A disco party. Now this is just one out of many ways to handle input in Godot, but since we're focusing on the GDScript language, I'm not going to go further into it here. I'll make sure to provide a link to where you can learn more about input if you're interested. Variables 1.0. Variables are essentially containers that hold information. In the case of a player character, we could use variables for information like the player's name, health, damage, and perhaps if the player is alive or not. Let's make a health variable. At the top here, I'll write var for variable, the name of our variable, and then we'll set it equal to a default value. Now we can print this variable inside of our ready function. We'll write print. And if we play, you can see that it now prints 100. Now we can easily change our variable. So before printing, let's assign a new number. Health equals 40. We can also assign a calculation. So health equals 20 plus 30. We'll set our health to 50. We can also add health plus equals, and then 20 will add 20 to our health, and subtract health minus equals. To multiply, we do times equals, and to divide, we do slash equals. So if we run this now, it will do all of these calculations from top to bottom and then print out the result, which turns out to be 120. Let's look at an example where our player takes some damage and we want to subtract the damage from our health. Let's try decreasing our health variable whenever we press the action we made earlier. So in the input function, we'll check if the action was pressed, and then we'll subtract from our health, and we can print the result. So now every time I press the spacebar bound to my action, we can see that I reduce the health. Really cool. But as you can see, we can currently reduce our health below 0, and nothing happens when we do so. If we were making a game, we'd probably want our player to die and the game to restart. Luckily, we can make our game react to variables by using if statements. If statements, or conditionals. If statements are the glue that holds all of our logic together. We've actually already used if statements to check if our action was pressed, but they can do so much more. Yet they are really simple. An if statement is just a condition that needs to be met in order for the code inside to be run. Let's add an if statement here to check if our health reaches 0. So I'll make some room, write if health is less than or equal to 0. Well, then we'll set our health to 0, and we'll print that we died. And now when our health gets to 0, it prints you died. Now here we're using less than and equal to compare our health to the value 0, but there are many more comparisons we can make. Here are all the comparisons we use, such as is equal to, is not equal to, and so on. We can also add more conditions to one if statement. We use the and keyword to add another condition where both need to be met, and the or keyword to add a condition where only one of them needs to be met. Now one really useful thing about if statements is that we can not only define what happens when the condition is true, we can also choose what happens when it's false. We do this using the else keyword. Let's add an else to print that we are still alive if our health hasn't reached 0 yet. So if our health is less than or equal to 0, we died. Else, we print you are healthy. And even cooler, we can chain together if statements using else if or elif for short. So we check if our health reaches 0, and if not, else if elif, our health goes below 50, well then we'll print that we are injured. And if neither of these two are true, we'll go to else and say that we are healthy. And if we play, we can see that at 80 we are healthy, at 60 we're still healthy, then we're injured, and at 0 we die. Very cool. Note that the if statement we made here is nested under another if statement. You can easily layer if statements to get more and more specific functionality. However, try not to overdo it. You can quickly get lost in the ifs. Actually, a lot of people don't know this, but that's why programmers and philosophers have so much in common. We both tend to spend a lot of time with the ifs and the what ifs. So if you get frustrated along the way, remember that so was Plato. Anyway, that's it for if statements. Comments. We use comments to help explain and remember the what and the why of our code. Adding a comment is simple and can be done above or after a line. So if you have some code, you can make a comment above the line, and this is a comment about the code that follows, or we can make one right after. And this is a comment about this line only. We can also use comments to temporarily remove parts of our code from being executed. Here we simply put a hashtag in front of the code. And it's good practice to omit the space here to indicate that what follows is code. We can also select multiple lines of code, right-click, and toggle comment. Just remember that you can't have a completely empty function. We need to add the pass keyword to avoid an error. Variables 2.0. When creating or declaring a variable, we need to think about where we do so. If we declare a variable inside of an if statement, for example, we can only use that variable inside of the if statement. This is called scope, and it's something that beginners often make mistakes with. If we want to use a variable in many different places in our script, we make sure to put it at the top, outside of any functions. So this is a script-wide variable. This can be accessed anywhere in your script. If you were to declare it inside of a function, you would only be able to use it in that function. So this is a variable we can only use in ready. Now, a really cool thing about variables in GDScript is that you can declare them without thinking about what type of data is inside them. Here's a variable that is either true or false, and here's a variable that stores a number. As you can see, they're created in the exact same way. In fact, we can even change the type of data that they hold just by reassigning them. So we can actually set our coolness to true, and this runs completely fine. That being said, we still need to be aware of what type of data we're working with, because some parts of our game will expect a specific type of data, and we will get an error if we try to use another type without converting. Now, in GDScript, we have the 4 classic data types: Boolean, or bool, for true and false, integer, or int, for whole numbers, float for numbers with decimals, and string for text. Converting from one type to another is called casting. For example, we can cast an integer into a string. So if we have a number that is equal to 42, we have some text, which is a string. Well, then we can add the number to this text, but we convert it into a string by writing str for string, and then the variable inside of the...
Oof. Feel like I'm sleepy. Feel like I'm gonna pass out. I should hop off, probably. I should hop off. I should figure out how to code in Godot on my own. Or just like take a nap or something and then, you know, figure it out, and then probably come back and try to code this game. Oh, I think I'm too tired. I'm done. I already coded in assembly earlier today. And it's like, it's getting late. It's not that late. It's like 4:30 p.m. But yeah, I feel like hopping off for now. I think I'm gonna call it. Even though I took like a 15-minute break earlier, I don't think it helped that much because I sat down and I'm sleepy again. So we're gonna find someone to raid and we're just gonna call it. But if you're on YouTube and you're watching, please click that subscribe button that lights up when I say subscribe. And I will see you later. Do remember that you are all stars, and I